Hello everyone, welcome back to Diksha Karnataka YouTube channel. So today is the day before your exam, so penultimate day for physics. I have collected all the doubts possible from your end, and I will be discussing all the possible doubts that you might have from the chapters. So here the discussion will be happening in two parts. First part is basically where I am going to discuss all the chapter wise important questions and the doubts that you have from those chapters. Okay, in between, if you want to add some more doubts, that also I will try to accommodate as much as possible, but the doubt should be based on the chapter itself. So I request you to join the chat right now and post your doubt only from the chapter that I am going to discuss. Okay, once your turn comes, suppose you have a doubt in atoms chapter or nuclei chapter, it will be the later part obviously. So we will start with the chapter 1, electric charges and fields, and we will see all the important questions from that chapter, and then we will see if you have any doubts from that chapter or not. Okay, otherwise we will proceed, and at the end, once everything is done, all the doubts, all the concepts are cleared, we will be solving 30 most important expected MCQs again along with you, so that you just get preparation for your tomorrow's exam. Then we will close this session. Okay, and there will be a 30-minute revision video tomorrow just for your before exam, some very important derivations, some very important questions, very short 30 minutes revision. It will be uploaded tomorrow morning at 4 AM. So let's see the first doubt that I have received, that sir, should I read NCERT textbook for physics? Right now there is no time for reading NCERT for physics. If you had time at the beginning of the year, NCERT textbook should be you should have read NCERT book at the beginning, not at the last day of your physics exam. Okay, so right now you don't have the time. Just check, if you have not studied anything, you can check the yesterday there was a video of top 50 questions. Just check that out. You will sure shot score 40 plus marks. Okay, that is my guarantee. Okay, if you check all the questions, practice all those 50 questions, then definitely you will score 40 marks. There was no numerical in that video, so if you are worried about. Now let's see the first chapter, electric charges and fields. If you have any doubts, yes, whatever rocking thoughts, if you have any particular doubts, mention that in the comment below chapter wise. I will explain the concepts as well. Okay, if you have any particular doubt in that chapter, suppose I am discussing electric charges and field, and if you don't understand what is the meaning of this, these all questions are discussed multiple times. Okay, so that is why I have just jotted down all at one place. Later on the PDF will be available in our WhatsApp channel through the drive link, so you can check that out. You can make it a checklist. Okay, I have studied this, I have studied this, I have studied this, I have not studied this, so what should I do for this question? Either you can search for in our videos, or I have done all the videos in 2 marker 3 marker section. All the 2 marker 3 marker sections are done. In 5 marker obviously derivation videos are done. Some I have not done, some videos, some concepts I have skipped. I will tell that what is all important, what you can skip from this as well. Okay, these are the consolidated chapter wise concepts. Sir, I know only Adistar, I know only few questions, I forgot everything even after practicing. What to do? Adistar, you have to write them, okay, at least twice. Okay, you have to write them twice, and your mind may be too much distracted, so focus on one thing at a time. Okay, for example, right now you check, okay, these are the questions, can I answer them? Just close your eyes and try to visualize the answer. What is the answer for this question? State and explain Gauss's law of electrostatics. What is the answer for that question? Okay, I know that there is something about charges. So charge enclosed by a surface is times something is something. So what is that? So you have to remember that flask, electric flask through a surface is basically charge enclosed by the surface times 1 by epsilon naught. As simple as that. So you have to close your eyes and try to visualize the answer. That is a good way to revise right now, because you don't have too much time to write everything. At the beginning of the year, if you are studying, then you have to write them. Right now you don't have the time, so try to close your eyes and visualize. Don't read anything new, okay, unless it is very essential. Practice whatever you have solved. Don't try to read anything new, okay. Watching a video is still fine, because there you are not reading, I am explaining, that is still okay. But if you try to read or do anything new, you will not be able to remember whatever you have studied. Okay, so that is very, very important. Whatever you have studied, try to consolidate those questions. Okay, that is very, very important right now. Now this is a consolidated questions. All types of questions are included. Gauss's law, Coulomb's law for vector form. So you have studied Coulomb's law, but you don't know what to do for vector form. So vector form, you have to draw a diagram. That is compulsory for explaining Coulomb's law in vector form. So you have to draw the diagram Q1, Q2. Okay, so you have to show that this is r cap. Okay, any one of them can be r cap, but suppose you are saying this is the force. Okay, this is the another force, this is negative force. Okay, one is plus F, means another one is minus F. So F equals to 1 by 4 pi epsilon naught Q1 Q2 by r square r cap. So this is a explanation of Coulomb's law in vector form. This is the Coulomb's law in vector form, easiest Coulomb's law in vector form. There is a diagram given in your textbook also, you write that one as well, but this is the easiest one, where you have mentioned if this is force, this is negative force according to the third law of Newton's third law. So that is also fine, this is also be accepted as correct answer. Okay, where you have mentioned this is r cap, so your formula has everything required for it. So but if you have practiced the form given in your textbook, that is also fine, no problem in that. But you have to remember that when you are writing Coulomb's law in vector form, the diagram has to be there. Okay. Sir, numerical I have done alternating current. Yes, very good. Immortal I suggested, right. Please explain. So I just, as I said, I will explain chapter wise. So if you have any question, sir, please leak question paper at 4 AM. Please, sir, please leak question paper. Endless warrior. Yes, I will try to leak the question paper. Okay. Yes, Asperia, Coulomb's law is based on third law. I don't know why Ashok is giving thumbs down. So Immortal, you have done alternating current. The other choice, the wise choice should be ray optics. If you have if you don't have too much time, only one chapter if you want to practice from ray optics, most 99% chance that the second question will be from ray optics. There is a small amount of percentage of chances that might be from dual nature of radiation and matter, but we will come to that later on. So these are the important concepts. All the 2 marker 3 marker questions are compulsory. Okay, properties of electric field lines, properties of charges, they are very, very important question. Okay, torque on an electric dipole came very less amount of time, but if you have time, you can revise this as well. Now, amongst the 5 mark derivation, obviously the electric field due to a dipole axis around the equatorial plane, not equatorial plane, the axis is the must, that is most repeated, and the electric field due to a charged straight line. These two are the very, very, very important, you cannot skip those. Electric field outside a charged spherical shell is optional. If you get time, you can revise this as well. If you have studied this, not super difficult, obviously easy derivation, but there is a small chance this might come as well. So everything at one place, this is your revision tool. Now electric potential and capacitance, this is the there are some doubts from this chapter, so I will discuss those doubts that students have from this chapter. So what are the important concepts? Equipotential surface is the most important concept from this chapter. Okay, from their definition, shape for different cases. Okay, so they will ask you what is the equipotential surface for a constant electric field. So constant electric field, we know this is the constant electric field, so the shape will be parallel planes. So that you have to know to answer. Okay, for a point charge, the equipotential surface will be spherical. Positive charge or negative charge does not matter. If they give you negative charge, also spherical equipotential surface. Positive charge, also spherical equipotential surface. Normal point charge, also spherical equipotential surface. Okay. Sir, for 2 marker usually only charge plus and minus equipotential diagram and graph nichrome wire. Adistar, usually only plus and minus charge diagram is not coming, maybe. So for example, I have seen that write 2 properties of charges. Okay, write 2 properties of electric field lines also coming at 2 markers. Okay, so you cannot only say only I will study 5 questions and those 5 questions will come. Okay, that is not possible, but if you have studied, just remember, yes, plus minus charges might come. It is given in your previous year also, and it was given in your model question paper also, right? Now let's see capacitance of a parallel plate capacitor. Very, very important. So derivation as a 3 marker or the expression, the formula as a 2 marker, both has come in the previous years. So this is also very, very important. Combination of capacitors might come as a 3 marker question, or it will come as a 5 marker question with the previous some explanation. Okay, it has never come as single 5 marker question. So there will be 2 plus 3 breakup, so that 2 marker question might come, but this chapter does not have a 2 plus 3 breakup, so only 3 marker question is coming from this chapter. Now expression for energy stored in a capacitor, energy density, only expression is coming. Derivation is not part of the syllabus, so only energy stored in a capacitor, expression and the formula. That is formula, expression means formula, right? And energy density is also sometimes might come. So those 2 are important. Potential energy of a dipole in an external field, optional. It has come in the past, but it is optional, not star. It is optional. If you get time, if you have practiced this, you can study this. This is optional. Okay. Next is polar and non-polar molecules definition. Okay, centers for polar molecules, centers of positive and negative does not align. For non-polar, positive and negative align at normally. Okay, but under the influence of electric field, both will give you a dipole moment. That is the definition. Definition difference might come, so get ready. Just small definition. If you have studied it once, just revise it once. Now 5 mark derivation from this chapter. 5 mark derivation chances are little less. My expectation is that numerical will come from this chapter. Okay, as I said multiple times, derivation will come from electric field chapter, numerical question will come from this chapter. That is my expectation. I might be wrong, but there is a high chance that this chapter will be given as a numerical, because last year it came as electric field was given as a numerical and electric potential was given as a theory question. So generally they alternate every year, but you do not know what set of questions is going to come. They generally make 2-3 sets of questions and they randomly pick one of the set of the questions. Other sets are carried forward for the test, revision test 1 and revision test 2, or whatever you say. Now this is not revision test, it is improvement test 1, improvement test 2, right? So we do not know, but mostly my expectation is that numerical question will come from this chapter. Anyway, the theory, most important derivations are electric potential at a point due to a point source charge and electric potential due to a dipole. This is an optional question. Some student asked me about this, so I am going to explain that in the next part, but this is optional. It has never come in the board exam in the direct first paper. It has never come. It has came once, I think, in the improvement exam. Okay, it has never came in the main exam ever. Okay. It has came in the pre-board papers or college papers, but it has never came in the board paper. Okay, I want to understand the derivation of parallel plate capacitor. This is the doubt from this chapter by some of you. Okay, I want to understand the derivation of parallel plates capacitors, expression for energy stored in a capacitor and effective capacitance of parallel and series combination. So he has asked a lot of questions. Even though I have discussed everything, let me discuss it briefly so that you get the idea that we have a parallel plate capacitor. How to find the capacitance of that? So parallel plate capacitor means it is a charged plate, right? It is a charged plate. So charged plate means it has a electric field. Okay, now if you consider a very long charged plate, there is a electric field due to a charged plate. What is the expression for electric field due to a charged plate? Electric field due to a charged plate is basically given by sigma by 2 epsilon naught. What is sigma? Sigma is charge per unit area. Okay, sigma is the surface charge density. Surface charge density. So due to the positive charge it will be positive, due to the negative charge it will be negative. Outside the plates, so there will be electric field on both sides. Okay, electric fields will be on both sides. So because they are in this direction and this direction, and it is constant. Okay, it is constant. So outside the plates, electric fields due to positive plate and negative plate, they will cancel each other. Okay, but inside the plate, you can just mention that outside the electric field cancel each other, but inside they do not. So inside, what happening is, electric field due to positive plate is away, electric field due to negative plate is towards. So basically both electric fields are in the same direction, so they will add up. Okay, so electric field due to negative will be the same value. Okay, it is independent of the individual charge, but it is dependent on the charge density, which is very, very important. Also there is no distance dependency in the electric field, if you remember. So in total electric field, how to find total electric field? Both of them are in the same direction, so definitely they will be added. So 2 epsilon naught plus sigma by 2 epsilon naught. So you can say sigma by epsilon naught is common, it will be half plus half. So half plus half is 1. So the total electric field will be sigma by epsilon naught. This is the first stage. Okay, now you have to apply another law. Suppose the potential between the plate is V and the distance between them is, say, small d. Okay, then we know that electric field is basically dV by dt, but in this case V by d. Okay, so electric field is V by d. Now that is basically this sigma by epsilon naught. Okay, or sigma equals to epsilon naught by d into V. Okay, not done yet. Now we said that the sigma is surface charge density. So surface charge density means if total charge in a capacitor plate is Q, the surface area of the capacitor plate is A, then sigma is basically total charge divided by the surface area. So that will be epsilon naught by d into V. Okay, or Q equals to epsilon naught A by d into V. So these are the steps you have to remember. First you have to say that outside electric field is 0, inside electric field is not 0, and both of them are in the same direction, so they will add up. So total electric field is sigma by epsilon naught, and then you can say this. Now we know that Q equals to C into V. This is the known equation. So if you compare these two equations, say this is equation number 1, this is equation number 2. If we compare them, we can say that C equals to epsilon naught A by D. So this is the expression for capacitance of a parallel plate capacitor. Okay, so this is the derivation. If you do the derivation, 3 mark questions might come from this. Otherwise the formula you have to remember for sure. Okay, there is a high chance one question based on this simple formula will come. Either they will ask you write the formula for write the expression for capacitance of a parallel plate capacitor and explain the terms, or they might say that on what factor that the capacitance of a parallel plate capacitor depends. Okay, so parallel plate capacitor depends on directly proportional with area, inversely proportional with distance. Okay, so these are the two factors that it depends on. Also what is this epsilon naught? Epsilon naught is the free space permittivity. If you add a dielectric medium between them, then there is a dielectric constant K is also added, so it also depends on dielectric constant, but in this derivation dielectric constant, no need to add dielectric constant, and even if you write the expression dielectric constant, you can skip that. Okay, if you want to add that in the only expression part, you can do that, but in the derivation that is not required. Okay, so I hope your doubt is cleared. Now next we have, right, if you want you can check that doubt again if you are not watching right now. Syed is saying derivation electric potential due to isolated point charge is also important or not. Yes, Syed, this is the very important derivation from this chapter, no doubt about that, but my personal intuition is that there might be, you have to practice that, there is no doubt about that, you have to practice that electric potential due to a point charge. I also mentioned that in the important chat, the expression of the electric potential due to a point charge. Okay, that is no skip, you have to study that. Okay, this came last year, it might come this year as well. Okay, but my personal experience and intuition says that that may not be the case, maybe electric potential related numerical will come from this year. That is my intuition, but you have to practice, there is no point on that. Okay, sir, can you just revise about polar and non-polar molecules when placed in an electric field? Yes, I can do that. Let me just finish this quickly, then I will go back. Okay, expression for energy stored in capacitor, expression for energy stored capacitors is basically half CV square. This is the energy stored in a capacitor. Energy density is half epsilon naught E square. Okay, these are the two very important formulas you have to remember, and they might ask you the expression and then explain the terms. So C is capacitance, V is potential. Here epsilon naught is the free space permittivity, E is the electric field between the capacitor plates. Okay, effective capacitance of parallel and series combination. Effective capacitance of parallel and series combination, very less chance of coming. I have done it multiple times. You can check any one of the videos in Brahmastra series as well. Okay, I am not going to discuss that unless you someone else also has problem with this. This is very simple derivation. Anyway, so effect of polar and non-polar. So what is a polar molecule? So let us understand in detail polar and non-polar. Okay, so polar, what happens is that they have a permanent dipole moment. Polar molecules have permanent dipole moment, so their centers of positive and negative charges do not align. Example is your favorite. Every day you drink that, without it we will not live, we will not survive, H2O. Okay, so what happens is that the lone pair goes towards the oxygen. Okay, the electrons slowly moves towards the oxygen. Okay, so that is why this becomes 2 delta minus, and this becomes delta plus, this becomes delta plus. So effectively there is a dipole moment of this polar. That is why water is called polar soluble, right, solvent, and there is a effective dipole moment in this direction. Okay, so this is an example of polar molecule. Now non-polar, for example carbon dioxide, for this the center of positive and negative charges always coincide with each other, so they do not have any separation in normal case. Now when you apply an external electric field, what happens to the polar? Okay, and they align, initially they align such that the negative positive randomly oriented, but eventually what happens is that they cancel each other. Okay, they are randomly oriented such a way that they cancel each other, so net dipole moment is still 0. Even though molecular level there is a dipole moment, net dipole moment of the system is still 0. Non-polar, obviously net dipole moment is 0. Now when you apply an external electric field, what happens is that these dipoles, they align themselves, try to align themselves in the direction of applied electric field. Okay, so we know that negative charges move opposite to the electric field and positive charges move in the direction of electric field, so they tend to align themselves. In case of polar molecules, they align themselves. Okay, so that there is a electric field developed inside the dipole as well. Okay, there is an effective electric field developed inside the dipole as well, and that electric field basically electric field is positive to negative, so there is a electric field developed inside the dipole moment, which is basically reducing the effective electric field inside the material. Okay, so which is basically reduce the, so suppose this is polar so it reduces the effective dipole moment, effective electric field inside the material. That's it. In case of non-polar, what happens is that, okay, when you apply an external electric field, okay, these molecules which were normally staying at plus and minus together, the plus charge is carried away by the electric field, whereas the negative charge is carried in the opposite direction of the electric field. Negative charges basically move. So what happens, the molecule gets separated, the charges slowly separated from the center. So they also develop a dipole moment inside in the presence of external electric field. So both polar and non-polar will have a dipole moment under the influence of external electric field, whereas in case of polar, the dipole moments, already existing dipole moments, will align according to the applied electric field, and in case of non-polar, the center of the positive and negative will separate, so molecules will not move. In this case molecules move themselves to align. Okay, in this case molecule is static, only the charges are moving. Okay, charges are separating, basically electrons are moving, even center of nucleus does not move, we know that it is heavy, so only electrons move slightly in the opposite direction of electric field. Again there will be an internal electric field, so almost same thing happens if it is polar or non-polar. Only advantage is that in case of polar molecules, they already have one external electric field, they already have an dipole moment, so their field, this EP is slightly stronger than this ENP. So dipoles, polar molecules are very good at reducing the external electric field. Non-polar molecules are also good in reducing the electric field, but not as good as compared to polar. That is the basic thing. Okay, under the influence of electric field, both the centers separate. Okay, any other question? Derivation of Biot-Savart's law is important or not? So Samreen, I will come back to that when the chapter comes. Please explain reflection of light and the basis of Huygens wave theory of light. I will explain that, Samreen. Rahat sir, you have given the numerical enough, sir. Yes, Rahat, if you study all the numericals I have given, you will definitely able to solve 2 numericals. That is my guarantee. You will get more than 3 numericals. That is also my guarantee. Okay, if you have solved all the numericals in yesterday's session, if you have seen that, also I have done a very important all numerical session. If you watch that, definitely 2 up to 3 numericals you can get. Okay, not 4, up to 3 numericals definitely you will get. Okay, now let's move on. Obviously this is a promotion for our Abhyas KCET test series. If you have not yet registered for Abhyas KCET test series, the link is given in the description. Those who want to prepare for KCET and want to practice KCET exams, so that you don't feel that, sir, what I have to study, what is the important questions, what are type of questions come in KCET. So everything will be covered in this test series. So if you are still waiting, don't wait. Register yourself now and get 4 free test series which is available with our channel, and later on after your PUC is over, we will be launching full-fledged 21-day not crash course, full-fledged 21-day test series. There is a crash course, residential crash course, wherever you are, if you want to participate in that, that is also very good. That is a Lakshya KCET test series. Okay, that is residential happening in our Diksha campus. So if you want to join that, you can join that as well, and there is a special reward for all the toppers. For that you can check the detailed video that is available in our channel. Right, that was the trailer of this. Before I came live, there was a trailer going on, so that trailer was about that. Right, now next is electric current chapter. Now electric current chapter, even though it's a very small chapter, there is a very huge vast concept to cover. Drift velocity, mobility, relaxation time, their relationship, their intermediate relationship. So if you have not done the relationship part, you just read their definitions. derivations. If you remember the relationship, that is very good, but internal relationship sometimes come. What is the expression for mobility, what is the expression for relaxation time? So that is very, very important. Other than that, if you have not studied that definition, so definitely you have to study. Diff velocity is most important. Okay, limitations of Ohm's law, another write 3 limitations of Ohm's law, write 2 limitations of Ohm's law, also very, very, very important. Difference between current and current density, it is a recent question but might come. Resistance and resistivity, dependence of resistance with temperature, how resistance change with length, how resistance change with area, that is important. And resistivity, okay, there is a student asking that resistivity of nichrome wire and silicon. Yes, that is a graph that is from this chapter, so that is also super important. So nichrome wire is basically, it almost changes very small amount with temperature. If you change the temperature very high, the nichrome wire, the resistivity changes by very small amount. Okay, and for silicon, this is from nichrome wire. Okay, and for silicon it will be reduced with temperature. So if you increase the temperature, its resistivity decreases. Okay, so this is the 2 diagrams that you need to remember before, just a quick revision, right? Now 5 marker questions. Cells in series and parallel are super important in this year. Wheatstone bridge is also super important. We expected this question will come last year, it did not came. So this year Wheatstone bridge is very, very important. Okay, it will come because 2023 also Wheatstone bridge came, but as a 2 marker or 3 marker question. Only they ask you to draw the circuit diagram and write the condition for balance. Derivation does not came. So I am expecting this year derivation will come from this chapter. Also one numerical will come from this chapter. Numericals from this chapter are difficult. That is why I don't recommend it. So some student asked me this numerical in the Google Drive. This is actually from your model question paper 2, I think. Right, Manisha sir, 25 numericals is enough. 25 numericals is enough, Manisha. The exact value will not come, but the concept that is given in the numericals will definitely come. Obviously I cannot say that the values will given the same. Okay, so values will be different, but the concept, the formulas that we used, how we have solved the problem, the approach to a problem will remain same. Okay, over the years there is no change, either electric field, electric potential or electric force. So everything that we have tackled, all the concepts we have covered through those numericals, and there is a high chance that exactly similar numericals with different values will come. That was the trend in the past. Okay, so I have solved +5 and -5 microcoulomb. In the board exam there was -3 +3 microcoulomb. So these are the trends. 90% cases these questions will come, and as I said, 2 numericals you will definitely get. 3 will be, if you are slightly luckier, 3 you might get 1 extra option as well. Okay, but 2 will definitely you will get. No questions asked. If you study all those 25 numericals, 2 questions you will get for sure. Now this is the circuit. This is from your model question paper 2. I have solved this question in the model question paper 2. If you have not seen that, you can check that. I will briefly explain how to solve it. The problem is very bad problem. It is a very long problem, not super easy. Okay, so first of all, this 2 ohm, which is a internal resistance of the battery, you have to consider it to be a 2 ohm over here. Okay, similarly here also 1 ohm is here, that you have to consider as a series resistance. So internal resistances, they generally become series resistance with the battery. Okay, now here as you can see that I3 is basically because of I1 coming in and I2 coming in. So I3 is I1 plus I2. So this is the first stage. So I3 is nothing but I1 plus I2. This is the first stage from Kirchhoff's current law, right? Current is coming, this is the incoming current, this is also incoming current, but this is outgoing current. So sum of 2 incoming current is equals to outgoing current. So I3 equals to I1 plus I2. Now you have to apply Kirchhoff's voltage law in 2 loops. First is this loop. Okay, I will form the equations. Solving is part up to you. So we will always start with the positive of the battery, that is easier for us. So we will start with the positive of the battery and we will move in the direction like this. We will close it. Now also I told you that if I current exits a battery, then that same amount of current should enter it back because of the conservation of charges. So if I1 current is going here, the current which is coming back should also be I1. Okay, these are the important things that you should remember. Okay, if I1 current is exiting, I1 current will enter. Similarly, I2 current is exiting over here, I2 current will come back as well. Okay, so these are the basic things. Now we will apply Kirchhoff's voltage law. So first we are going in the direction of current, right? This case, so we are going in the direction I1 into 6, that is 6I1. Then we are going through this loop, I3 into 10, so plus I3, 10 I3, that is 10 I3 plus 4 I1. Okay, so I1 is entering, so I1 should pass through this resistor as well. So 4 I1, and that should be equals to 4, that is the voltage. Okay, so this is the first equation, and we have to put the value of 10 I3. Instead of I3 we have to put this I1 plus I2 plus 4 I1 equals to 4, or so 4, there is also 2, there is a 2 I1, sorry, 2 I1 is also there. This is the first resistance, this is the first resistance, so 2 I1 is also there. Okay, so 2 I1 plus 6 I1 plus 10 I2, 10 I3 plus 4 I1. So if you add them, you will get 4 plus 6 plus is equal to 10, 10 plus 10 is 20, 20 plus 2 is 22. So 22 I1 plus 10 I2, 10 I2 equals to 4. So if you divide all the terms with 2, you get 11 I1 plus 5 I2 equals to 2. So this is equation 1. Okay, now you have to apply the same thing in this loop as well. So you will go again in this fashion, so that we are going in the direction of the current. Okay, so what is the first part is 1 ohm is there, 1 ohm, 1 into I2 plus 6 I2 plus 10 I3 plus 4 I2, and that should be equals to the EMF, that is 2 volt. Okay, now add them. 6 plus 4, 10, 10, 11 I2 plus 10 into I1 plus I2 equals to 2, or 10 I1 plus 21 I2 equals to 2. So as you can see, this is basically AX plus BY equals to C kind of two equations, and the coefficients are not super simple, so it will be very complicated in only solving the mathematical part. Okay, if you can solve this very good first, that is why I always say that you can skip the numericals from electric current chapter, because not only you have to form these equations correctly, okay, then you have to solve them as well. Solving itself is another query. Okay, so some of the students asked me, one student asked me, sir, I am solving the numerical question. If my final answer is not correct, how much marks will be deducted for that? So that depends on two things. If your final answer is not matching because you made a mistake in the last step, final step, you will get up to 4 marks. Okay, 4 marks you will get sure shot. But if you make a mistake at the first line, Okay, if you make a mistake in the first line, then most probably you will get 0 marks, even though you have done it correctly. If there is a circuit diagram involved, okay, not this is already given in your exam, so you have to draw this circuit diagram, copy the circuit diagram in your answer sheet. But if you have to draw a diagram to solve that problem, diagram is required to solve that problem, and if you have drawn the diagram properly, you will get 1 mark. Okay, and if you are making the mistake at the beginning of the problem by making some small errors or anything, then there might be up to maximum up to 2 marks you can get. Okay, even if you have used the formula, suppose your formula was correct but you have calculated it incorrectly because of some mistakes, then up to 2 marks you will get, because that marks future marks will be not counted because that step itself is wrong. Okay, first step maximum 2 marks. Okay, minimum obviously 0 marks. Last step, if you make mistake, you can score up to 4 marks. So don't worry about it. So if your only final answer is wrong, but you have done almost all the steps correctly, maybe 1 or 2 steps you make a mistake in the final calculation, 4 marks you will get. Okay, I have shown you the toppers paper. In that paper, a student make a mistake in the final result, and 2 final results was incorrect, but his approach was correct. So he got 3 marks for that paper, but that was an extra question, so that was not counted. Okay, but if you almost correct the question, you can get up to 4 marks. Okay, at the last stage. Okay, any doubt, any other doubt? Caster Sudeep, is model question paper is there is a deviation that the cells connected in series with different EMF. I am unable to find the solution. Caster Sudeep, that same question I have solved, right? This question you are talking about. Derivation, that cells connected in series with different EMF. You are talking about cells in series with different EMF, right, Sudeep? Yes, equivalent EMF, same as equivalent EMF, same question. Okay, cells in series with different EMF is same as equivalent EMF. Okay, so only thing that you have to do that, this is very easy, right? Cells in series, I hope you if you remember, I have done it multiple times. So cells in series means there will be 2 cells. Okay, and always remember, so whenever they are talking about cells, there will be some internal EMF. So epsilon 1 R1, epsilon 2 R2, so they are basically connected in series. Okay, so you have to find the equivalent EMF. So this is the R, right? This is the same thing. Epsilon equivalent will come out to be epsilon 1 plus epsilon 2, and if R equivalent will come out to be R1 plus R2. Okay, this is the derivation, right? Can I get the answer? No one is explaining it. Caster, I have done it multiple times. In you can check my all derivation section, you can check the respective model question paper as well. Let me do it quickly. Okay, let me do it quickly. So we have 2 cells, epsilon 1 R1, epsilon 2 R2, they are connected in series. Now in case of cells, we have to connect a resistance in the series with them. Now what is common in series connection? In series connection, common thing is current. In parallel combination, common thing is voltage. Okay, so in series combination, the current through all the components will remain the same. Okay, now as soon as you draw this, you have to draw the equivalent circuit as well. What is equivalent circuit? In equivalent circuit, there will be only one cell and one resistance. The external part will remain the same. So this is the given circuit, this is the equivalent circuit. We are trying to find epsilon equivalent and R equivalent. Okay, how to do that? First, what we will do, we will apply the Kirchhoff's voltage law. So Kirchhoff's voltage law says that current into resistance, so IR. Okay, now we will go in the loop. We will say what is the current here? Same current in series combination. So plus I into R2 plus we will skip that battery for now, we will consider only the resistance. So I into R1, okay, equals to whatever is the cells connected, epsilon 1 plus epsilon 2. Okay, from this we will calculate what is the value of IR. So IR equals to epsilon 1 plus epsilon 2 minus I common R1 plus R2. You can take one more step if you are not confident how I have done it. So I have taken the I common R1 plus R2, then I have taken this thing to the other side. Okay, now the same thing you have to do, this is for the given circuit, same thing you have to do for the from equivalent circuit. From equivalent circuit, what we can say that same current will pass. What is the meaning of equivalent circuit? That we replace multiple things with only one and everything else remains the same, right? So we replace the two cells with only one cell, but the current etc. will remain same, the external component will remain same. So that is how we calculate the equivalent part. So equivalent circuit means what is the current? Current is I, resistance R, plus IR equivalent, and that should be equals to the potential that is connected here. Okay, or from there you can say IR equals to epsilon equivalent minus IR equivalent. Now if you compare equation number 1 and equation number 2, what you get? You get this must be equals to this, right? No other way. Now this current at the component of current must be equal to component of current here as well, right? So we can say that from comparing 1 and 2, we can say epsilon equivalent is equal to epsilon 1 plus epsilon 2 and R equivalent is equal to R1 plus R2. Okay, I hope that helps. Sudeep. Ponas, sir, can you please revise the formula for alternating current? Yes, I will come back to that. As soon as we go to the alternating current chapter, I will revise. Yes, sir. Prism explain, please. Okay, I will do the prism explanation also. I have done multiple times. Okay. Hello Adistar, Nigesh. Okay, wait Mari, I will come back. Okay, I will come whenever the chapter is coming. I will explain the corresponding doubts that you have. Okay, so first of all, moving charges and magnetism, Lorentz force is very, very important from this 2 marker, 3 marker, and even new objective questions will come. So Lorentz force is very, very important. Angular frequency, radius of revolution for a charged particle, very, very important. mv square by r equals to q b v. Remember this equation. Okay, from there angular frequency is omega. Okay, omega is r, v is equal to r omega. So from there you will either be asked to calculate radius you can calculate directly from this. Okay, or if they ask you omega, then you have to remember v is equal to r omega. Substituting that, you need to find the value of omega. Sometimes they will ask you r, sometimes they might ask you cyclotron frequency or normal frequency as well. Frequency is what? Frequency is omega is equal to 2 pi f. So these are all the important equations that you need to remember to tackle this 3 marker question. There is a high chance there is a 3 marker question based on this will come. Okay, force on a current carrying wire, BIL sin theta or normal BIL, very important. Biot-Savart's law statement, super important. Diagram, super important. Okay, someone was asking something about Biot-Savart's law. If you please let me know. Ataur Rahman, sir, if we see your 100 most important MCQ, how much can we score in MCQ? Ataur Rahman, if you understand the concepts, the logic behind it, you can score 15 out of 15, no doubt. Okay, the exact MCQs will not come, but the logical reasoning that I have applied to solve those MCQs will definitely be helpful for you. Okay, so that is very, very important, understanding the logical reasoning. It is not about reading the MCQs and solving it. Yes, that is a practice session. We will solve 30 more MCQ in the practice session. You can come and check that out. Okay, so Biot-Savart's law, super important. Ampere circuit law, it came one or twice. Okay, and maybe small application that, but I am not going for that right now. galvanometer to ammeter, ammeter to voltmeter, galvanometer to ammeter, galvanometer to voltmeter, also super important. It has came in the past as well. Now in the derivation part there will be one derivation sure shot from this chapter, magnetic field at the point on the axis of a circular current loop, very important, and force between two parallel current carrying wire. Both the derivations are super important from this chapter, easy derivations. Practice it at least once or twice so that you can answer it. Okay, now let's move on to the next chapter. Magnetism and matter, easy chapter. I don't want to waste too much time on this chapter. Difference between dia, para, ferromagnetic, any one of the difference will come. Properties of magnetic field lines, Gauss's law of magnetism, magnetization and magnetic intensity, magnetic susceptibility and relative permeability. These are the important concepts from this chapter. Only 2 mark or 3 marker question come from this chapter. No derivation from this chapter. Now next is electromagnetic induction. Again small chapter. Faraday's law, Lenz's law, expression for self-induction, coil magnet experiment, motional EMF. These are all important concepts. Small chance of a numerical might come from this chapter as well. Now there is a question, explain Fleming's right hand and left hand rule. Someone asked this question. So I will explain what is Fleming's left hand and right hand rule. So both hand rules are for different cases. Okay, so for example, what is Fleming's left hand rule is for? So Fleming's left hand rule is there when you have a current carrying wire. You have a current carrying wire, okay, and you kept it in some magnetic field. You kept it in some magnetic field. So current carrying wire is there, okay, so it is primary. This magnetic field will always be there. Now if you point your finger, this finger in the direction of magnetic field, this finger in the direction of current, then your thumb will point the direction of force acting on this wire. Okay, so for example, magnetic field is in this direction, okay, current is in this direction, so force will be out of the page in this case. Force will be out of the page in this case. This is the Fleming's left hand rule. Fleming's right hand rule on the other hand is about induced current. Okay, so in this case what is the thing in induced case, induced magnetism, what happens? First we move something and then the current induces. Okay, so same thing, the fingers remains the same, that is this is magnetic field, this is the current, but in this case this is the motion. So this is primary in this case. Okay, magnetic field and motion are primary, induced current is secondary. Okay, that is the induced part. Whereas in case of left hand rule, okay, magnetic field and current are primary, the motion is secondary. Okay, so that the only thing is that magnetic field is always primary, current in the case of induced current right hand rule it is secondary, motion is primary. Okay, so this is very important. I hope the person who asks this doubt, I have cleared their doubt. Left hand rule is for force on a magnetic current carrying wire in magnetic field. Right hand rule is induced current because of the motion in a magnetic field. Okay, now let's move on. Alternating current, someone asked, I think just before I came here, sir, is there any other question that might come from alternating current other than numerical and MCQ? Very less chance that there will be a question coming. Only you should look for transformers, okay, which is part of this chapter. 2-3 losses in a transformer, how to prevent it. Only one concept that you have to study, and what are the formulas that is important from the chapter transformers. So you asked it, I am going to give you. So first thing, step 1, there will be L, there will be a C, there will be a R. Now L and C may be there, may not be there. Okay, in some cases you will see only CR circuit or only LR circuit. Okay, but R will always be there in the circuit. LC is not there, individual LC is not part of the syllabus, so R will always be accompanying. Okay, so either RC or RL will be there. Okay, now the formulas that you have to remember, the frequency is given F. mostly it will be 50 hertz. Okay, in competitive exam they give a better value so that you can cancel it, but in the board exam frequency will be 99% cases it will be 50 hertz. Okay, there will be 220 volt mostly. Okay, 220 volt, 50 hertz, supply is there, LCR is there. So first stage what you have to do whenever you are solving numerical from this chapter, first stage is calculate XL. XL is 1 upon 2 pi f into L. Okay, 2 pi f into L, and if you are lucky, if you are super lucky, instead of giving f they give you omega, angular frequency. Okay, if you give you omega, the same thing is basically 1 upon omega L. Okay, so this is the formula. This is 99% board exams related to these questions only, but if you are super lucky, obviously there is no pi, so calculation becomes easier. So omega might be given to you just for safekeeping. You just remember this equation. What is sorry, this is not XL, my mistake, this is XC. This is XC. Yes, sorry. So this will be omega C, 1 upon 2 pi fc or 1 upon omega c. Now what you have to remember is that generally capacitance is given in microfarad, millifarad, picofarad. Okay, so whenever you put that value, and if it is given in microfarad, okay, so C is suppose given 2 microfarad. So microfarad means 2 into 10 to the power of minus 6. Okay, so how to tackle that in these cases? So what you have to do, you have to take that 10 to the power of minus, that should go up and it will become plus. The regular values, whatever values are given, okay, say 50 hertz, 50 hertz is given, so the rest of the values will be in the denominator. Okay, so this will help you to solve this kind of values quickly without using without much help of a calculator. Okay, only a pi value you know, 3.14, put that value and calculate it. Okay, and if you are comfortable with uncomfortable with 10 to the power of 6, you can even reduce some of the values. Okay, 2 into 50 is 100, so 2 into 50 is 100 means what you will get? You will get 10 to the power of 4 divided by 6.28. Okay, 10 to the power 4 means 10,000. 1, 2, 3, 4 divided by 6.28. Now you can do this using your calculator, whatever value it is. Okay, so that is very important. XC is first you have to calculate XL and XC. Okay, XC is little critical, XC is little tricky because of this 10 to the power of minus 3 minus thing. Okay, so be careful. While inserting the value, there will be a microfarad or millifarad in case of C, so that you have to be careful about. Okay, number 2, obviously XL is easy, 2 pi FL, and as you know 2 pi F is nothing but omega, so it will be omega L. Okay, this is the primary formula, this is the formula, good to know. Now what else? Second is the impedance of the circuit. What is impedance of the circuit? Impedance of the circuit is R square plus XL minus XC whole square. This is the impedance of the circuit. Okay, as simple as that. Now 4 is the phase angle. Phase angle, if it is phase angle is phi, then this is tan phi. Okay, tan phi means it will be XL minus XC by R. Now here you have to remember that in case XC is greater than XL, what you have to do, you have to take the modulus of that. So no negative sign is here, no negative sign is allowed. Okay, so always subtract bigger minus smaller value from bigger value minus smaller value. That is the thing you have to remember. Okay, in case you find that okay, this is 100, this is 10, then you have to do 100 minus 10 always. So take the modulus of that. This is the phase difference. And one more thing, okay, one more thing, power factor. If they ask you power factor, they will definitely ask you to calculate the impedance. Power factor is same thing, cos phi. Okay, you can calculate phi from this equation, and again you can use it to calculate cos phi, fine, but there is a shortcut way to calculate cos phi, which is basically R by Z. This is called power factor. Okay, this is the other formula. These 5 formulas, mostly your work should be done by this top 4. This is a good to know formula, and in case you don't know how to use tangent table, you don't know how to find the value is very odd, you are not able to find the exact angle, don't worry, you leave your answer phi is equal to tan inverse whatever the calculated value you have received. You will get the marks for that. Okay, you will get the marks for that. Don't take too much tension about tangent series. And tangent series also I explained in yesterday's live session briefly. Only the closest value matters. You don't need to get the exact value. Okay, if it is 57.8, 58 will be considered correct. So check whatever is the closest value. Based on that you can approximate your answer. That is also very acceptable. Okay, and if you don't know anything to do, you can leave your answer like this. That is also acceptable. Your process is correct, your method is correct, only you have not calculated tan inverse, you will get full marks. Okay, so don't worry about that. Okay, phase difference anyway, the only thing, all other values you can directly get it. I hope your doubt cleared, Ponas. Okay, can we keep FAI is equal to tan inverse something? Yes, phi equals to tan inverse something. You can keep, I said multiple times, you can keep your answer like this, you get full marks. This is not the thing that they are looking. They are looking, okay, you have applied the formula correctly or not, you have understood the concept correctly or not. That is the checkpoint. This is not the checkpoint. Okay, this is one of the checkpoint, but mostly board exams, they generally give you a value which is comfortably you can calculate. If they don't give you, then you can leave answer like this. And one more thing I forgot to mention, that there are 2 more things, current and voltage lagging. Someone will lag, someone will which is lagging, which is leading. So if XL is greater than XC, then current lags. Okay, if XC is greater than XL, then current leads. Okay, so this is the 2 things that you have to remember apart from these formulas. And formulas are very straightforward formulas. Okay, not super difficult. Write it twice, you will remember it. Solve 1 or 2 numericals, you will remember it. Okay, that is why from the beginning, if you have followed my lectures, I always suggest practice numericals from alternating current, because there is not super heavy mathematics involved, not super heavy conceptual integrators are there like circuit theory. Okay, where you have to apply Kirchhoff's voltage law, Kirchhoff's current law, then simplify it, then solve it, which is a very long process. Here you straightforward apply the formula, solve it. Okay, so only thing is this is a conceptual part, current lags or current leads. Okay, this is the main 2 things. Other than that, if you have any other doubt from this chapter, so sir, overall all chapters, formulas for problems, overall all chapters, I will try to give you a quick revision tomorrow. Right now there is not many formulas there in your to solve your numericals. Okay, you can check the 25 numericals I solved yesterday. Only Coulomb's law, electric field and force, they are the main things. And in ray optics chapter, lens equation, and what else, lens in combination, simple formulas, not complicated formulas. None of them are complicated formulas. Okay, unless you are preparing for KCET, where if you remember a shortcut formula, you will save some time. Not required, basic formulas are sufficient. Okay, these are the important formulas I have given you at one place. So these are the very important formulas from this chapter, ray optics, no, alternating current. I will give you ray optics formulas as well. But that formulas I hope you already know that. Now EMOFs, small chapter, 2 marks maximum will come, and one objective question 3 marks. So different applications of EMOS. So application of IR waves, application of X-rays, application of UV rays. So those are type of questions that comes from this chapter. And displacement current, what is displacement current, write the expression for it. Okay, that is also might come from this chapter. Other than that, this is a very simple chapter, nothing to worry about. Ray optics, so you are asking about formulas for numericals. There are 2 formulas, 1 by V plus 1 by U equals to 1 by F equals to 2 by R. This is for the mirror equation. This is mirror equation. Okay, lens equation is 1 by V minus 1 by U equals to 1 by F, lens equation. Okay, and what else? 1 by F equals to N minus 1, 1 by R1 minus 1 by R2. But you don't even have to do that. Okay, what you should remember is this should be 2 by R. This is the lens maker equation. Okay, this is the lens maker equation. So if you put the R1 equals to R2, R1 equals to minus R2, you will get this value. Okay, sign convention has to be applied in all cases. Okay, this is lens maker equation. Power of lens equals to P equals to 1 by F. Okay, two lenses in contact, F equals to F1 F2 by F1 plus F2. Okay, and in that case total power equals to power just gets added. Okay, so these are the formulas from this chapter. Simple formulas, nothing, no rocket science is there. Okay, I hope I covered. And one more total internal reflection related question, sin theta c equals to 1 by n. This is another formula. And prism problem, n equals to sine a plus delta m by 2 by sine a by 2. These are the other formula that you need to remember. Okay, so these are the formulas from this chapter, all at one go. Now what are the important concepts? Sign convention, there is a sign convention diagram. Okay, so there is a so any distances along the positive x-axis is positive, any distances along the negative x-axis is negative. Okay, any distances you are measuring in the positive y-axis is positive, any distances you are measuring in the negative y-axis is negative. Okay, so that is why u is always negative. For concave surfaces, focal length is negative. Concave lens, concave mirror, focal length is negative. Convex surfaces, convex mirror, convex lens, focal length is positive. Okay, so this is the diagram. You need to remember it, you need to draw the diagram, and then you have to show this u is negative, object height is positive. Okay, object height in the below is negative. So this is the basic diagram you have to draw, and mention the sign convention. It has come in the past, might come in your year, easy question. Just remember to draw the diagram, rest is very easy. Along positive x is positive, along positive y is positive, along negative x is negative, along negative y is negative. As simple as that. Okay, focal length is r by 2, derivation might come, very less it has come, but if you get time, practice this, otherwise skip that. Total internal reflection, condition for total internal reflection based on this MCQ might come as well. Telescope, okay, what is the uses of telescope, different types of telescopes, why telescopes are, what are the different types of telescopes, objective lens of telescopes, and the FO by FE, that is the magnification of a telescope. So that is might come as well. Power of a lens, what is the power of a lens, how does it vary with focal length, that is the one question. Now 5 mark derivation definitely come from this chapter. Lens maker's equation, refractive index of a prism, refraction at a spherical surface. So some of you have asked me the explanation of the refractive index of a prism. So I will briefly do it. I will tell you what all you have to write. You don't need to do a lot of things in this. This is very easy question, so don't put too much pressure. So what you have to do, first stage is to draw the prism. Okay, draw the prism. Diagram should be drawn clearly using pen or pencil, but it should be very clear. The angles you should mention properly. The angle of deviation should be mentioned properly. So this angle is angle of deviation, this angle is A. Okay, this is angle of deviation. Okay, this is the angle of incident I, this is angle of emergent E. This internal angle is R1, this is angle R2. Okay, now you don't need to mention too much, you don't need to show the geometry. What you have to mention, that from geometry, okay, from geometry, the angle delta is basically I plus E minus A. Okay, angle delta equals to I plus E minus A, and what is A? A is R1 plus R2. This can be proved from geometry. You are doing physics, geometry is not your task, but you have to remember what you are getting from the geometry. Results are important. Okay, from geometry of the prism. Okay, from the geometry of the prism, delta is I plus E minus A, and A is R1 plus R2. These are the important part. Now after that you have to draw the diagram. After that you have to draw the diagram of the delta versus this graph. Okay, delta versus I graph. Okay. So delta versus I graph, the minimum deviation graph, that is the suppose this is delta, this is I. If you draw the graph, you will get something like this. Now what is the meaning of this? That is, for a single value of delta, you are getting two angle of incidences. So basically you can say that one will be angle of incidence, another one will be angle of emergent. Okay, but at a particular value, or that is the minimum value of delta, where the delta is minimum, you are getting only one value of I and E. It is not theoretically possible to derive or prove. It is coming from experimental observation. This is from experimental observation, that at the angle of minimum deviation means when the graph is at its lowest point. So when the graph is at its lowest point, at this point, only one line you can draw towards the I-axis. That means at this point, angle of incidence should be equals to angle of emergent. Okay, so you have to draw the graph, and then you have to mention that at angle of minimum deviation, this is delta mean. Okay, at angle of minimum deviation, angle of incidence is equals to angle of emergent. Now if these two angles equal, then their internal angles will also be equal, right? So if at delta mean, at delta equals to delta M, okay, I is equals to E. Therefore R1 must be equals to R2. Okay, now the same thing you have to put it here. Calculate I will be A plus delta M by 2, and R will be A by 2. Right, if you put those values, you will get these values. Now from Snell's law, refractive index is nothing but sin I by sin R. Okay, if you put the value, you will get this result. Simple derivation, only marks is drawing and how you explain it step by step. That is very important. Refraction at a spherical surface, Manisha Pradhan, that you can skip. Refraction of the spherical surface has come very less amount of time. Lenses are more important. Okay, I have done it in all derivation video in the Brahmastra series, if I remember correctly. Okay, but right now what the suggestion is saying, that you can skip that. If you have not studied it, skip that. Don't worry too much about it. Okay, you will find all the other derivations solvable. Don't worry, my guarantee. Okay, Lensmaker's equation you practice. Lensmaker equation is slightly tricky, where you have to draw two levels of refraction. Okay, and refractive index of prism, most likely this year refractive index of prism will come, not super sure. Out of these two these two are important. Okay, this one, if you have studied it, study it. This is optional, you can skip it if you have not studied it. Okay, and in my opinion this is very difficult. Also don't waste too much time on this, you skip that part. Okay, these two are very likely to come, so that is why this is the last number. Okay, I gave you, if you have studied it, okay, no, if you have not studied it, skip that. Okay, got it? Prism diagram clearly. What prism diagram you want to ask? Manisha, Yash, okay, Yash, wait. So this is the prism. Okay, so a ray of light, this is the incident ray. Once it falls on a prism, it bends towards the base of the prism. Okay, and then it emerges out of the prism like this. Sorry, it emerges out like this. Okay, now you have to draw a normal on this surface. Normal means you have to take a scale and then draw the normal. So this is the normal. Okay, normal, and the angle made by the normal with the incident ray is called angle of incidence. Okay, this is the first ray which is going into the prism, we call it R1. Okay, then you have to extend this ray. Let me draw it using a different color. You have to extend this ray and you have to extend this ray. Whatever is going out, you have to extend these two rays. They will meet at some point. Okay, that angle is called angle of minimum deviation delta. This is the angle of minimum deviation delta. So if you extend this ray and this ray backside, then wherever they meet, use dotted line obviously. Okay, then they are, that angle is angle of minimum deviation. You have to draw the normal at this point as well. So normal at this point will give you this is the angle of emergent E, and this is the internal angle, this is called R2. Okay, and this is the angle of prism A. Okay, now geometry, you can use geometry, triangular geometry, find all the angles, that is fine if you want to do that geometry, but that is not required. That is not required in this case. You have to do a lot of mathematics. First of all, this angle is I minus R1, this is E minus R2, then this is the outside angle, so you have to put that. Now you have to take this rectangle, then you have to show that R1 plus R2 is basically equals to A. So these are the derivations that you can do. Okay, but I say that is not required from the geometry. It is evident that I plus E minus delta is equals to A. Okay, or on the other side, I plus E minus A equals to delta, whatever you are comfortable with, and secondly, A is equals to R1 plus R2. These are from geometry. You don't need to prove it. Okay, you can mention from geometry. You have to mention from geometry of the prism, we get it, right? Yes. Ponas, yes, Wheatstone bridge is important. I gave you that Wheatstone bridge in the discussion, current electricity chapter, right? Mukesh, yes, Mukesh, what is your doubt? it's Aishu, I already mentioned Wheatstone Bridge. Okay, I also mentioned, if you have listened to that area, I said Wheatstone Bridge, we were expecting Wheatstone Bridge will come last year. It did not came last year, so we are expecting again this year. So last year they changed it to combination of cell, I think. We do not know if they change it to combination of cells again, but we are very much expecting that will be the question from that chapter. Okay, but there is no 100% guarantee. It was, so as you say, the fixed question. Some teachers say that last year Wheatstone Bridge is fixed question, it will come. So all the students practiced it, but it didn't came. So that is why always have at least one or two good options in your hand. So there is nothing called fixed question, even though it is very, very important, super important, but it did not came last year. So what can you do? So if it is not coming two back-to-back year, means that is a big thing for Wheatstone Bridge, right? It did not came in 2023, it did not came in 2024. It should come in 2025, but if it does not come, then you will say, sir, Soumik sir said that Wheatstone Bridge is a fixed question. So I don't say fixed question, but it is very, very important. Yes, right? Now, next is wave optics chapter. Wave optics chapter, Huygens principle. Okay, now remember that from this chapter there is a high chance of a split 5-marker question coming. So split 5-marker question means so laws of reflection and laws of refraction will not be a sole 5-marker question. There will be a split question. So for example, explain what is Huygens principle, or state Huygens principle and explain this. Okay, that is very, very good chance of coming like this. Okay, condition for maximum and minimum in interference, coherent, incoherent sources of light. What is coherent light, what is incoherent light, diffraction of light, Malus law, uses of Polaroid. Okay, now in Malus law I want to remind you one thing. Okay, if you see a small derivation or a small numerical question, or in fact if you see any MCQ question, Malus law states that when a plane polarized light enters into a Polaroid with an angle theta, the emergent intensity is I naught cos square theta. But if there are two Polaroids, okay, and unpolarized light enters, okay, you have to remember that this is also very, very important for KCET, this concept. Okay, if an unpolarized light enters, okay, of intensity I naught, then after the first polarization, the intensity becomes I naught by 2. This is very, 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 very important. And then once it goes to the second Polaroid, then you apply Malus law. Okay, first you cannot apply Malus law here it will be flat I by 2, 50% discount. First case it is 50% discount, second case you have to apply Malus law. So I naught by 2 cos square theta. Okay, this is how you should remember it, right? Cells in parallel, cells in parallel came very less amount of time, but it has came. But obviously cells in series is more important. Cells in series is easier than cells in parallel. Okay, it has came in the past. I cannot say it has not came. It came I think before pandemic. Okay, so back then there was a tendency of the question paper little bit difficult. From this year onwards, there was some rumor that the question paper might be difficult this year, but from the trends that we have seen in the Kannada paper as well as in maths paper was not difficult. It was well within the reach of the students. Maybe scoring 70 out of 70 is difficult, but 65 plus is easy. Okay, so that is one thing. So from there we are getting the hint that maybe the paper may not be super difficult. Okay, but it will be average. Scoring 70 is always difficult. They give you at least one MCQ which will be critical, one or two MCQs which you might find difficult. Okay, but 65 plus should be easily gettable. Okay, so don't worry too much about parallel. If you have not studied parallel, skip it. You will get other questions so you can answer. Okay, dual nature of radiation and matter. One student asked about, I forgot the doubt, what is the condition for interference maximum and interference minimum? Please explain. So interference maxima happens at delta x equals to when the x is even multiple of integral multiple of lambda. Okay, so if it is n lambda, then it is called, it is maximum. This is for maxima, interference maxima. Okay, and here n is equals to 0, plus minus 1, plus minus 2, like that. Okay, now this is the condition for maxima. And minima, path difference, phase difference is, phase difference, in terms of phase difference, it should be n pi. Okay, n pi should be n pi, no, 2n pi, I think 2n pi should be the answer. Okay, 0, 1, 2, 3, 4, same value of n. Minima, condition for minima delta x is n plus half lambda. Okay, n plus half lambda. Okay, or some books write it 2n plus 1 lambda by 2. Some books write it like this. Again, n can be from 0, 1, 2, 3, same value. Okay, this is the minimum condition. So basically maxima means when two waves interfere with the same phase. So this is wave number 1, this is wave number 2. If they interfere with same phase, then you get maxima. If they interfere with opposite phase, one is maxima, another one is minima, then the resultant wavefront becomes flat. That is the minima, that is called minima. Phase difference is odd multiple of 2n plus 1 pi by 2. Okay, so these are the main things. Right, now let's move on. Dual nature. Yes, I want 70. Yes, yes, always I say your target should always be 70, nothing less than 70. Okay, but if you are not getting 70, then slightly less is also not bad, but you should not lose the focus in your mind. 70, 70, 70. If you lose that focus, then your marks will drop. Okay, but if you focus on 70, then there is a high 90% chance that you will get 70. But if you focus on, okay, I will score 40 marks or 50 marks, 50 marks is good for me, then you will not even score 50 marks, you will score 30 marks. But if you score, if you target 70, maybe 69 or 68 in worst case scenario. Okay, for example, last year also 1 or 2 MCQs were little tricky. Okay, 1 or 2 MCQs are little tricky. So even though the student who got 68, he said I could have got 70 because I made a mistake in one MCQ, that's why I got 68. Okay, so 70 should be your target, there is no compromise on that. Okay, but sometimes luck is not maybe in your favor that day. So but instead of 70, maybe 69 you can. It is very sad, I know. I had faced this situation in many times because of some cases I was not able to score out of out. So scoring out of out, missing out of out by 1 mark is very heartening, but still that will be your career will not be damaged because of that. But if you target for 70, you settle for 69, good. You target 50, you settle for 40, not good. Okay, so obviously dual nature, experimental observation of Leonard and Hallward observation, photoelectric effect, Einstein's explanation of photoelectric effect. Now these are the important definitions: photoelectric effect, threshold frequency, work function, stopping potential. Graphs, only if you get some time you can check the graphs of the photoelectric effect. Okay, for say constant frequency with different intensity, right? Constant frequency with different intensity, that is like this. So constant frequency, different intensity means saturation current is different but stopping potential is same. This is one case. Another case is different frequency but same intensity. In that case the saturation current will remain same but the stopping potential will vary. And there is one more, frequency versus stopping potential versus I don't remember it. So there was one more graph which is like this. Okay, I think stopping potential versus frequency response. Okay, so that is the another graph you need to practice. So these are the graphs that you need to check once. If you have not studied those graphs, you can skip that part, or completely optional. May come, may not come, not super important. Now this, from this chapter, if any 5 marker derivation comes, that will be a 2 plus 3 split wise. Okay, Einstein's equation and explanation. Okay, any combination of 2 plus 3 might come. Okay, sometimes they have even given the definitions as a 3-mark question as well. So any 2 plus 3 combination might come. Now someone asked me this doubt: mention Einstein's photoelectric equation and explain the symbol with the experimental results using this relation. So let's see the answer for this. So this is Einstein's equation. This is a doubt asked by the student. They didn't find the answer for this 5-marker question. It is from the model question paper. I have answered this anyway. So this is h nu plus half nu plus 5 plus half mv square. This is the Einstein's equation. Okay, explain the terms. Explain the terms means you have to explain all the terms: Planck's constant, frequency, work function, mass of electron, velocity of electron, everything you have to explain here. And how to explain this? Obviously Einstein's explanation is given. Einstein suggested that each photon of light has energy proportional to its frequency nu, given by E is equal to h nu, where h is Planck's constant. When light shines on a metal surface, photons transfer their energy to the electrons in the metal. Any energy from the photon exceeding the work function becomes the kinetic energy of the ejected electron. So that is the main part. So total energy that is supplied by the photon is basically doing two things. It is overcoming the work function, and remaining energy is converted into kinetic energy. That is very simple explanation by Einstein. Okay, if you remember that, you can answer it. Okay. Now atoms and molecules, there are a lot of questions from students regarding atoms and molecules. Are they going to ask derivations? So as you can see, there is no derivations from atoms chapter. Second question was, can I skip atoms and nuclei, sir? If you have not studied atoms and nuclei, you can skip them very well. Okay, not super important chapter, because obviously you can expect questions from other chapters. 2 marks, 3 marks, 3 to 4 marks question might come from this. MCQ we have to answer. There is no option in that, but theoretical questions you can skip from this chapter, right? Sir, after watching your previous video of 50 important questions, how much marks you can get? Presenting TGZ, 40 marks guarantee. 40 marks guarantee if you watch that 50 questions. Okay, I expect you to score 50 plus. Okay, including MCQs, then 5 marker fill in the blanks. Okay, 50 plus. If you study little, if you study everything in that 50 questions, and if you do well in MCQ and fill in the blanks, 50 plus is guaranteed. Okay, other than that, definitely you can score 40 plus. Okay, that is for weaker sections. Those who have not studied throughout the year, sir, give me some very important questions I want to study. So that is like that. Okay. Sir, please tell how to identify the value of sine inverse, tan inverse and cos inverse. Please tell what is the relationship between binding energy and mass defect. Okay, I will tell you that. Wait, next chapter is binding energy and mass defect. I will come. But before that, there is also one question yesterday, de Broglie's explanation of Bohr's second postulate of quantization. So de Broglie said that electron cannot stay in any arbitrary orbit. It can stay only in orbit where it can form the stationary wave. Stationary wave means what? It should close down. Okay, so number of wavelength, it should be such that they should close down. So if you remember the stationary wave you studied in PU1, so they should form a closed loop. Okay, so that is what this stationary wave means by. So de Broglie proposed that the electrons exhibit wave-like properties and their motion in an orbit can be described by a standing wave. For the electrons wave to form a standing wave around the nucleus, the circumference of the orbit must be an integer multiple of the electron's wavelength lambda. So he said 2 pi Rn equals to n lambda. From here, from de Broglie theory, de Broglie's wave theory, we know that lambda is basically h by Pn. From there, if you put Pn means Pn is momentum, so momentum is mvn. N we are saying that for nth orbit, obviously. From there, we can calculate that mvrn equals to nh by 2 pi. So what is mvrn? Mvrn is the angular momentum. So angular momentum is integer multiple of h by 2 pi. That was second postulate of Bohr. So that is how you can prove. So proof is not important. The explanation and this much is important. If they ask you proof, maybe you are unlucky, but if you practice it, that is also super simple, not difficult. You just need to put the value of lambda h by mv. It will rest of the things you can automatically get. Anyway, so this is the question that is asked. Now next part is nuclei, binding energy and mass defect, their relations, and there may be some related numericals. So binding energy, first of all, what is mass defect? Let me explain what is mass defect. So you have a nucleus. In the nucleus you have certain number of protons, certain number of neutrons. Okay, now generally a nucleus is defined by mass number and its proton number, right? Mass number and proton number are given here. So mass number is given by Z. Z is mass number and proton number is Z is number of protons and mass number is A, atomic number. Atomic number or mass number is given by A. Okay, Z is number of protons. So a nucleus, suppose X is represented by ZA or AZ, sorry. AZ. This is how we write, right? Now, if you measure the mass of the individual component, that is mass, total mass of the protons plus total mass of the neutrons, okay, then you will surprise that the actual total mass of the nucleus is less than that of the individual masses. So what is the meaning of that? You went to a shop, you buy 10 apples and 10 oranges. Okay, you buy 10 apples, 10 oranges, say 1 kilo orange, 1 kilo apple. Okay, now you put both of them into a bag, you tie the bag, now you wanted to measure them again. So what is the total mass of the orange? Orange was 1 kg, apple was also 1 kg. So what you expect? You expect that when you put that into a bag and measure the mass, you should get 2 kg. But instead of getting 2 kg, what you got? You got 1.9 kg. So that's why you are surprised. What happened to them? I am getting 100 gram less than what I am expecting. So basically the same thing is happening inside the nucleus. Okay, you can consider Z as apples, neutrons as oranges, but when you put them together, the actual mass is what? Is less than that of the individual particle masses. Okay. So this defect, this is called mass defect. Okay, and binding energy is basically mass defect into C square. This is binding energy. Okay, binding energy per nucleon, binding energy per nucleon is delta MC square divided by total number of nucleons, that is A. Okay, this is binding energy per nucleon. Now, when you are calculating binding energy, if they give you a numerical, you don't need to multiply with C square. What you can do, if delta M is in the unit atomic mass unit, that is U, then binding energy is basically 931.5 into delta M. This is the formula, okay, in MeV, unit. Okay, this is another formula that you should remember. Okay, so mass defect is when you measure the individual masses and you find that that is actually greater than that of the total mass, right? I hope. Samrin, which question you are talking about, Samrin? Today we are not discussing answers, questions. Yes, if you study these questions, all the questions I have given you. Also, Ataur Rahman, I hope your doubt is clear. Formation of PN junction, Bharat. Yes, I will do that. Coming to that chapter. Hello, Brooklyn. How to measure tan inverse? You can go back yesterday's live video. At the beginning of that video, after I think after 5-6 minutes, I explained how to identify tan inverse or sine inverse value. Both I have explained. Okay, now semiconductors, diode, band theory of solid, very important. Energy gaps with diagrams. What is the band gap for conductor? What is the band gap for semiconductor? What is the band gap for insulators? Okay. Intrinsic and extrinsic semiconductors. Also try to remember few examples. What you should add to get P-type and N-type semiconductors. Okay. So in part of extrinsic semiconductor, definition is very important. Biasing of a diode, how you can bias a diode, how to bias a diode. Formation of PN junction, even though that is not important and it has never came in the board exam, in the main exam. It came once, I think, in the supplementary exam. But formation of PN junction is simple. What you do, you take a silicon or a piece of semiconductor. Generally, we take a silicon, okay, and then we start doping it. From one side, we dope it with a trivalent. From other side, we dope it with a pentavalent. Okay, so from one side, suppose we are doping with aluminium. From other side, we are doping with, say, phosphorus. Okay, so this is how it is formed. So once you start doping it, a single silicon crystal, very important, that there used to be a question that in can we create PN junction by taking a P and a N and joining them together? No, it is not possible. What is important is that it has to be a single silicon crystal, and you have to dope it from two sides. Generally, first we dope with P and then we dope with N. Okay, so once they are completely doped, there is a region formed in between where this P and N basically mixing. So we are doping with 3 means this is the P side, we are doping with 5 means this is N side. Okay, so what happens is that N side has very high amount of extra electrons, whereas P side has high number of holes. Okay, so what will happen? Normally, if you leave them, the electron will try to go and find a hole so that they can neutralize and become zero. Now, normally, even though it is doped with pentavalent material, normally the total charge on both sides are zero. It is a neutral, electrically neutral. Total charge is still zero. Now, what happens to the N side is that it is losing electron. So, losing electron means what? Losing electron means it will slowly become positive. Okay, losing electron means it will slowly become positive. So, negative N type is getting positive, whereas P side, which is gaining electron, they will become negative. Okay, now because of that, what happened is that another electron who is trying to go to the other side, this is getting repelled by the this existing negative electric field. Similarly, a hole who is trying to get another electron, it is getting repelled by this positive electric field. So this internal electric field which is forming from negative side to positive side is called depletion region, and it is called potential barrier. Okay, so this potential barrier is what? It's stopping any further mixing of electrons and holes. Okay, so this region is called depletion region. In the depletion region, there is no active charge carriers. All the active charge carriers are depleted. That is why it is called depletion region. So if they ask you what is the majority charge carrier in depletion region, there is no majority charge carrier in the depletion region. No active charge. Okay, to forward bias it, what we have to do? We have to connect a positive of the battery with P side and negative of a battery with N side. So what does it do? This positive will reduce this negative and this negative will reduce this positive. Slowly the depletion region will be narrower and it will be forward bias. This is the explanation for biasing of a diode. Okay, I hope Bharat your doubt is clear. Amish, band theory. So band theory is basically the entire explanation is really complicated. You can read that, but I will explain what is the basic of band theory. What band theory says that all the electrons that take part in chemical reactions, they combine together for a crystal. For individual atom they are different levels, but in the crystal their energy levels are very close to each other. All the atoms in a crystal are at somewhat different than others, so their energy levels are even though they represent the same energy level, their actual energy is not same. So they basically gives you a zone, a region having same energy level. That is called band. That is what the starting point of band theory. Okay, it only happens in crystals. So for a crystal of all the atoms or all the atoms that you can consider, molecules also you can consider, whatever is the part which take part in the chemical reaction, we call them valence shell or valence orbit, right? Now in this case, in case of band theory, that all the orbits of different atoms combined together, they gives rise to called valence band. Okay, this is the most important part of the atom, right, which takes place in chemical reaction. Now if you give little more energy to the valence band electrons, okay, sometimes it can come out and it can move freely. Okay, move freely means even though it is still bound to the nucleus somewhat, it is bound to the crystal, it is not bound to the nucleus. Okay, individual atomic level it is not bound, crystal level it is still bound. That is, the charge is still zero, but it can move freely. If you give it little electric field, it will be able to move freely. That level, the energy that you need to supply it to make it free, that will also vary from atom to atom, and the corresponding band is called conduction band. Basically, if you consider, for example, suppose this is an atom, okay, this is a nucleus, this is say valence orbit. Okay, the next orbit, which is empty right now, okay, if you can take this electron somewhat this orbit, okay, then this is called conduction orbit. So electron becomes somewhat free from the influence of the atom and it can move freely based on the applied electric field. This is called conduction orbit, just next orbit. Okay, so this is the basic theory, starting point of conduction and valence band. Now based on the material, whatever you are considering, the distance, the gap between conduction and valence band varies. Okay, the gap for conductors is basically 0. That means their conduction band and valence band overlap. For conductor, energy gap is denoted by eta. Okay, it is 0 or very close to 0. Okay, for semiconductors, for conductor, this is conductor, this axis represents energy. Okay, now for semiconductors, suppose this is valence band, this is conduction band. Okay, the energy gap is less than 3 electron volt, so that if you give sufficient energy, some electrons can get excited and reach conduction band at higher temperature. Okay, that is called semiconductors. Whereas for insulators, this gap is very high, higher than 3 electron volt. Okay, so this is higher than 3 electron volt, so that no electrons can ever reach valence band ever. Okay, that is why very rare cases 1 or 2 electrons might go, but they will soon come back. Okay, that high energy, it will not be able to stay there, it will soon come back. And insulators do not conduct. This is the basic part of the band theory. Okay, first of all, energy gap is very important. You have to mention, based on the energy gap, we can divide into the 3 materials: conductor, semiconductor and insulator. And basic part of the band theory is all the valence orbit combined together gives rise to valence band. Higher energy level, the next higher energy level combined together gives rise to conduction band. Based on the energy gap between valence band and conduction band, we can classify materials into 3 distinct objects, either conductor, insulator or semiconductor, based on the energy gap. Now, from this chapter, it is very, very important you practice full wave and half wave rectifier. So this is a chapter from where someone was saying sure short question. So full wave and half wave rectifier is almost sure shot. Okay, again 99.9%. There was no other question ever came from this chapter, but in the blueprint this question is there. So I have included this question for safety, right? Because it is given in the blueprint. If this comes, you may not say that, sir, I have not seen this question. But other than full wave and half wave rectifier, no question has ever came from this chapter in the last 5 years. Okay, so that is why full wave and half wave is very, very important from this chapter, along with this 2 mark 3 mark question. Okay, now we are solving some 30 MCQs. If you have any other doubt, what is diffusion current and drift current? So diffusion current is drift current is when you apply an external electric field. When you apply an external electric field, the electrons in the conductor or in the semiconductor, they tend to move in the opposite direction of the applied electric field. That is called drift current. Then diffusion current is when there are these electrons which are located at the n side. Okay, they move towards the hole side. Okay, so that is called diffusion current. This diffusion is basically happening when they are not moving under the electric field. Okay, because there is a hole, there is an electron, they try to diffuse with holes. That is called diffusion current. Okay, diffusion current is the mixture of electrons from n side to the p side. So as soon as the p-n junction is formed, okay, the current, diffusion current is very, very high, and then slowly it becomes 0. Okay, again when you forward bias it, okay, when you forward bias the p-n junction, again the diffusion current tends to increase. Okay, diffusion current again tends to increase, and it makes it forward bias again. Okay, so diffusion current is when the electron is moving because of the drifting of the applied electric field, whereas diffusion current is because of the mixing of holes and electrons. Okay. Sir, how can I get last 5-year question paper? It was there. I have seen it is in the Jeevith book. In the Jeevith book, the last of the Jeevith book, the last 5-year question paper is there. Chapter wise, last 5-year question paper is there, but it is not available in internet. Okay, I personally have 2 years question paper, which is very important for me, because only in last 2-year paper the paper pattern changes. Okay, the question MCQ questions were added. Before that, it was mainly objective questions. Okay, there was one word objective question, but not MCQs. MCQs came first time in 2023 exam, then 2024 exam. You are the third batch with MCQ in your syllabus. Okay. No, yes, I don't have the PDF. There is no PDF for this last 5 year. And in a fact, that last 5-year question paper, there is no PDF available. Okay. I have, because I was involved in teaching, I have 2 papers from last 2 years. Hopefully, I will get this year paper as well. But Before that, during pandemic, last I think 2020 exam was happened. That time I don't have the paper. Okay. Now let's see the MCQ questions. 30 MCQ questions we will be solving. Smiley, in intrinsic semiconductor, which is carry current? In intrinsic semiconductor or extrinsic semiconductor, only electrons can carry current. Okay, even in extrinsic semiconductor also, holes are basically do not move, they attract electrons. Okay, holes part is they attract electrons, electrons always move. Okay, maybe it is holes, maybe it is electrons. Holes is basically lack of electrons. Holes are what? Well, holes are lack of electrons, so they attract electron. By this way you can say that holes are moving. Protons do not carry any electrons. Only protons do not carry any, cannot move. They are bound to the nucleus. Only electrons can move, right? Okay. Mukesh is asking, sir, please, I have a doubt. Can you please explain me once what is intrinsic semiconductor? So intrinsic semiconductors are pure semiconductors, silicon and germanium. That's it. There are only two intrinsic semiconductors, silicon and germanium, which occurs naturally. Okay, and their conductivity increases with increase in temperature, which is odd because normal conductors conductivity decreases with increase in temperature, but for germanium and silicon, which are naturally occurring pure semiconductors, their conductivity decreases with their conductivity increases with increase in temperature. That is why they are called intrinsic semiconductor. Inside an intrinsic semiconductor, number of holes, number of electrons are same. So we say hole concentration is equal to electron concentration, right? Smiley, in textbook, hole and electron carry current they have given. Yes, so basically what is hole? Hole is lack of electron. Okay, but if you consider a charged particle, only electron can carry charge. Only electron can carry current. Okay, holes basically gives the sense that electrons are moving in the opposite direction. If holes move from right to left, electrons are moving from left to right. That is the major thing. That is the meaning of hole. Okay, and in semiconductor it is given some preference, but don't worry, if this question comes in objective, you can mention that only electrons carry current. Okay, don't worry about it. M. Girish is saying that does the paper will be easy? It will be easy. It will be easy. Not super easy, but sufficiently easy. So dipole moment is a vector quantity which is pointing from negative to positive along the axis of an electric dipole, positive to negative along the axis of an electric dipole, infinity to minus q, plus q. So it is from negative to positive charge. So we will be solving some 30 MCQ. Let us solve quickly and go back to our study. This is just for your preparation practice. Let's see who can answer most of the questions. So who wants to be the topper? Let's see quickly. Electric potential due to a negative point charge at a distance r is positive and varies with 1 by r. So what we are talking about? We are talking about electric potential due to a negative point charge, okay, at a distance r. Positive and varies with 1 by r square, negative and varies with 1 by r square, negative and varies with 1 by r. Let's see who answers this. Yash, mention question number please. Yes, yes. Smiley, no, Smiley, not positive, not positive. Electric potential is given by kq by r. So if the charge is negative, then potential will be negative kq by r, right? So there will be a negative sign. Now I have taken a modulus, so it will be negative and varies at 1 by r. Okay, so be careful, because the charge is negative, it will be negative. So option D. Mention question number please, so that I don't get lost. The following are statements related to self-inductance. The self-inductance of a coil depends on its geometry and on the permeability of the medium inside it. Okay, the self-inductance is a measure of electrical inertia and opposes the change in the current in the coil. Both statements are correct. Both statements are wrong. Only statement 1 is correct. Both statements are correct. Only statement 2 is correct. So self-inductance of a coil depends on the geometry and on the permeability of the medium inside it. So what is the formula for self-inductance? If you remember, self-inductance is mu naught n square A into length, I think, L. Okay, mu square A into L, n square L. So n is the number of turns per unit length, A is the area, L is length, okay, and mu naught is the permittivity. Now if you add anything inside it, then there will be a mu r multiplied with it. So definitely self-inductance depends on the geometry. Geometry means area, length, they are geometry. Okay, and the permeability obviously depends on the permeability. Self-inductance is a measure of electrical inertia. Actually it is called electrical inertia. It opposes the change in current, back EMF. Okay, so both statements are correct. So option C is correct. Let's see 3. No sir, no Ponas not 3A. Nischal 3C, yes, correct. Smiley, please explain about this self-inductance key point, sir. Intrinsic semiconductors, both the hole and electron carry current. Yes, you can write that. Self-inductance, but as I said, holes are basically lack of electrons, right? Please explain about this self-inductance is what is self-inductance? You have a coil. Let me quickly in 10 seconds let me explain. You have a coil, you connected it to some AC or some DC. What happened? The current is trying to increase in the circuit. So when the current is trying to increase in the circuit, this coil is trying to prevent this increase. Okay, this is only one coil, there is no single coil. So you have seen that coil magnet experiment, there was a coil as well as a magnet, but here there is no magnet. Now we know that a current itself has a magnetic field, right? The current, whenever a current is being through a conductor, it has its own magnetic field. So basically when the current is increasing at the initial level, that increasing current will have a changing magnetic field associated with this coil itself. So the same coil through which the current is being applied, that coil is trying to prevent the current change in current in that coil. Okay, so the single coil, that is called self-inductance. Mutual is when you have two coils. One coil through which you have applied the source and another coil through which you have not applied the source, you are just measuring the current. Okay, so these are the two cases. Self-inductance, only one coil who is trying to stop the current that is passing through it because of the mutual, because of the current induced in it. Okay. Now ray of light is incident on a glass air interface at an angle greater than the critical angle for the pair of media. Then the ray undergoes refraction only, partial reflection, total internal reflection, grazes the surface at the interference of the two media. Angle greater than critical angle. So what will happen? 4C, total internal reflection, right? I will not waste too much time. Statement based question. Statement 1. The resistivity of metals increases with increase in its temperature. Okay, increasing the temperature of metals causes more frequent collision of the electrons. Both 1 and 2 are true, and 2 is the correct explanation of 1. Let's see. Yashu, yes. Bonus, yes. Raj, everything is correct. It is 5A, both are true and correct explanation of 1. Okay, any doubt in that? You have any other option? Okay, let's move on. Next question. The Lorentz force is the force on a charged particle moving in a region containing only electric field, only magnetic field, both electric and magnetic fields, only crossed electric and magnetic fields. Let's see the answer. Venkatesh answered correctly. Raj also answered. Yashu also answered. Ponas also answered. Good evening, sir. Day before yesterday, I made a mistake by writing the question number inside the margin. I am also so much tense. Please help me. Don't worry. Question number is fine. Okay, they will not deduct anything. Question number inside the margin is okay. Don't try to write it. Try to write it anything on the right hand side. That is an old habit. I know many students they write question number inside the margin. Don't worry about it. It is fine, perfectly fine. Okay, unless and until you use the margin like 6, 7, 8, 9, 10 like that, then it will be difficult. Okay, because teachers has to give you the marks in the margin area. So that will be different, and you should not write anything in this corner, at the bottom corner. That is that is strictly prohibited. Okay, because after giving the marks, teacher should add the total marks of the page there. Okay, so that is strictly prohibited. If you have not made this mistake, then it's fine, don't worry. So obviously most students are correctly both electric and magnetic field. Okay, both electric and magnetic fields. Next question. Match the column. We can expect a match the column this year, because all the question papers has a match the column question in your model question paper. So we can expect one match the column. So I giving 2 seconds. Let's see the answer. Don't worry. Sir, compulsory register number solid be written in all pages. Registration number compulsory. If you take any extra page, yes. If you don't take any extra page, not necessary, because that is a single booklet. Okay, all the registration number, if you write it first time, it will be stay there. Okay, if you write it, okay. If you don't write it, that is also fine. But if you take a new page, additional sheet, it has to be written. Other than that, not compulsory. Okay, match the column 1 with appropriate into. Self-induced EMF is called back EMF. Okay, I already mentioned self-induced EMF is called back EMF. EMF induced in a rod moving in a magnetic field is motional EMF. P. Okay, AC generator, electromagnetic induction by changing the orientation, and transformer is mutual induction. So if you see that only one option with correct D match R you are getting, so option A is correct. Who mentioned option A? 7A, 7A, 7A. Yes, yes, yes. Sri Guru Gana Lahari Sangeeta Academy. Thank you, thank you. Okay. Yashu sir, they gave additional booklet. I wrote only registration number, not completed any details in the second booklet. Is it okay? If you have written your registration number, it should be fine. And if you have stitched it properly, okay. For physics, additional booklet is not required. Obviously maths paper, because maths paper they is sometimes get lengthy, so maybe it is required. But other than that, if you have written the registration number, if you have stitched it properly, don't worry too much about it. Okay, it will be taken care. It will be you will not travel thousands of kilometers. It will go from your examination center, it will go to the campsite. From there it will be under the supervision of the head examiner. So he will distribute the papers to the teachers who will come for the checking, and it will be done. Don't worry too much about it. Okay, unless some super disaster comes, your paper got torn, which is very unlikely. Okay, the average power dissipated in an AC circuit is maximum if the AC source is connected only to pure resistor, only to pure inductor, only to pure capacitor, to a series combination of capacitor and inductor. So average power dissipated in an AC circuit is maximum only to a pure resistor. Yes, correct answer option A. Yes, Akash. Now let's see, let's move on. The displacement current is due to flow of electrons, flow of protons, changing electric field, changing magnetic field. Next question occurs. That A part is done. Raj is saying 9C, Yashu 9C, Yash 9C, Ponas 9C. Yes, changing electric field is called displacement current. Now next move on. Statement 1, the net magnetic flux through any closed surface is 0. Statement 2, the number of magnetic field lines leaving the surface is balanced by number of lines entering it. Very common question. So net magnetic flux through a closed surface is 0 because number of field lines entering is equals to number of field lines exiting. So both statements are true and one is correct explanation. Yes, 10. Yash, mention the answer. Okay, Ataur, Yash, Anu, all of you are correct. So without any delay, let's move on. The electromagnetic waves with lowest frequency amongst the following: gamma ray, UV ray, microwaves, radio waves. Lowest frequency, not wavelength. Lowest frequency. Lowest frequency means higher wavelength. You have to understand that. So Akash is saying microwaves. Raj King is saying D. Nischal, there is no option R here. 11D. Yes. Akash no, it is radio waves. Radio waves is the highest wavelength, lowest frequency. Okay, microwaves is slightly higher frequency than radio waves and slightly lower wavelength. Okay, in terms of wavelength, radio waves have highest wavelength, and in terms of frequency, radio waves have lowest frequency. Gamma rays has highest frequency and lowest wavelength. Okay, gamma rays are highest frequency, lowest wavelength. Next, the current density is the scalar and its SI unit is ampere meter square, vector and its SI unit is ampere per meter cube, vector and its SI unit is ampere per meter square, scalar and its SI unit is ampere per meter. Let's see, this is a last year question. 12C, vector and its SI unit is ampere per meter square. A straight conductor of length L is moving with a velocity v in the direction of the uniform magnetic field strength B. The magnitude of the EMF induced between the ends of the conductor is. Okay, let's see. Yashu, Yash. Yes, so that is this is why I ask you to read the question before answering. Okay, so if you read that it is moving with the velocity v in the direction of the uniform magnetic field. So in the direction means if the motion is in the direction of magnetic field, okay, actually there is a BVL sine theta is there. Okay, that we often ignore because always we consider the motion is basically perpendicular to the magnetic field. Okay, that is the highest motional EMF. But other than that, there is a sine theta involved. If they are moving in the same direction, theta is 0, that means BVL is 0. Okay, so option C is correct. So you have to be careful. This is a full question, easy question but full question. So many students will see this is the formula for that. I will answer it, but actually it will be 0 because it is a vector quantity, and you can calculate this sine theta term. Sine theta we ignore it. Okay. Now next question: an object of finite height is placed in front of a concave mirror within its focus. It forms a real enlarged image, a real diminished image, a virtual enlarged image, a virtual diminished image. 13 is done. 14. Anu, these are just practice. Okay, if you practice it now, if you answer it today, then you will be confident for tomorrow, right? If you don't practice it now, if you think that okay, I have to remember all the answers, no, just for your practice. You see the question and try to answer how many you can do, right? So another Anu is saying it is C, option C, a virtual enlarged image. So object finite height placed in front of concave mirror within its focus, so it will be virtual and enlarged image. So that means the object is placed closer to the focal length. Closer to the focal length means it will be a virtual and enlarged image. Correct. Now next question: The ferromagnetic material among the following is copper, nickel, lead, calcium. Ferromagnetic material. Anu is saying option B, nickel. Yes, iron, nickel and cobalt are the common ferromagnetic materials. Okay, so this is a common example. Question number 16. In a purely capacitive circuit, if the frequency of AC is doubled, capacitive reactance will get doubled, becomes 4 times, get halved, remain constant. 15 was answered. 15 was yes. Smiley, it was not real because the distance is less than focal length. So distance less than focal length means it will be virtual image. Okay, for a concave mirror, if it is more than focal length, then it will be real image. Other than that, if it is less than focal length, it will definitely be a enlarged and virtual image. Okay, and based on the other location, you cannot say it is enlarged or smaller or bigger. For real images based on exact location, between C and F it becomes enlarged, beyond C it is smaller, but in this case if it is less than F it will always be smaller. Now this is a very interesting question. Srigauri, we are answering question number 16 now. Vignesh, no. Capacitive circuit. Capacitive circuit means only capacitance is there. So if you have followed me, I have given Xc is 1 by 2 pi Fc. So if you increase the frequency twice, then the capacitive reactance will also be halved. So capacitive reactance will be halved if you increase the frequency twice. So it will be get halved. Okay, no way it will become 4 times. Okay, so be careful while answering. The power factor of a series LCR circuit is maximum when XL is equals to XC, XL is greater than XC, XL is less than XC. No Tejas, no Vignesh. Power factor is maximum when the circuit is in resonance. Okay, circuit is in resonance and its impedance is equals to resistance only. Impedance will become resistance only if XL is equals to XC. Okay, because in case of inductor and capacitor, they generally do not consume any power in a complete cycle, but in case of resistor it consumes power. So if the circuit is completely resistive, then only the power factor will be maximum. Okay, so power factor is maximum at resonance. Those who will become electrical engineer in future, this will be very, very important for them. Okay, electronics engineer. If you want to design a radio, you need to know this. Question number 18. Which of the following phenomenon confirms the transverse nature of light waves? So let's see. Polarization of light, diffraction of light, dispersion of light, refraction of light. Yes, in case of diminish or in case of real images will always be inverted. You have to remember, Smiley, real images are always inverted, be it convex lens, be it concave mirror. Okay, real images are always inverted, but real images are enlarged or not, that we cannot say for sure shot. But virtual images, in both cases, concave mirror as well as convex lenses, virtual images are always enlarged and it is always direct. That is the main thing. Okay, so generally whenever they will ask the question, remember that they generally ask you virtual questions, virtual image related questions. Okay, because the fixed nature and the size is fixed. So 18B, Yashu is saying 18B, no. transverse nature of light wave is given by polarization of light. Okay, so transverse nature you cannot say that using diffraction. Diffraction says light is a wave. Okay, even sound gives you diffraction, because sound is not a transverse wave, it is longitudinal wave, but still sound gives you diffraction. Okay, diffraction is a property of wave. Dispersion is also property. Dispersion is not property of wave. Dispersion is a different property, where light is constituent of 7 colors, which has nothing to do with the wave property, by the way. Refraction of light is also nothing to do too much with the wave nature. Diffraction is one property which gives you the wave nature. Polarization on the other hand gives you the transverse nature of light. Okay, that is why you can block some of the light, but still the light will pass through it. Okay, so polarization gives you the nature, transverse nature. Diffraction and interference gives the wave nature. Okay, that is very, very important. When both light and sound show wave character, diffraction is much harder to observe in light. This is because speed of light is far greater. Light does not require a medium. Wavelength of light is far smaller. Waves of light are transverse. Ataur, sir, how in numerical, how to identify the nature of the image? So I give you two things. First of all, if you are solving, first you have to use the following sign conventions. Object distance is always negative. Okay, for concave, be it mirror, be it lens, focal length is negative. For convex, be it mirror, be it lens, focal length is always positive. Okay, now when you apply the problem, if you solve the numerical, okay, if you solve the problem, if you are solving it for mirrors, okay, if you receive that V is negative, if V is negative, then it's a real image, and vice versa. If V is positive, then it's a virtual image. Okay, for lens it is exactly opposite. If V is negative, then it's a virtual image, and if V is positive, then it's a real image. This is the only way to remember how to find the real and virtual images. Or one more thing you can do, based on the sign of V, very important, once you apply the sign convention, you find the V. Okay, try to understand where it is forming. Negative means left hand side, positive means right hand side. Okay, so if it is a lens, okay, right hand side image means it's a real image. If it is a mirror, right hand side means it is a behind mirror. Behind mirror means obviously it's a virtual image. Okay, that is one way to remember it. That is one way to understand it. If you don't understand it, you have to remember it. I don't remember it. I try to understand that based on the position of the V. If it is negative, negative means left hand side, positive means right hand side. That much is clear. Now based on if you are using a mirror or a lens, okay, you see that if it is happening on the other side of the lens, that means the image must be real. If it is happening on the other side of a mirror generally blocks the light. That means all the light is basically it's a behind the mirror. So behind the mirror means definitely it's a virtual image. Okay, that is the basic understanding you need to have. So obviously, what is the question? Answer to the question, wavelength of light is far smaller. Option C, 19C, yes. Sir, resonating frequency formula is okay, I forgot to give you the resonance frequency formula. Resonance frequency formula is 1 by 2 pi square root of LC. Okay, this is the formula for resonance frequency. Okay, question number 20, the gathering L is inductor, C is capacitor, but you have to be careful. Again, microfarad value will be given, so you have to be careful about that. 10 to the power of minus 6, once you do the square root of 10 to the power of minus 6, that will come out, it will become 10 to the power of minus 3, and then it will go up as 10 to the power of plus 3. I have solved few numericals yesterday, you can check that out. The gathering and focusing mechanism of light by the eye lens is described by, Ponas is saying 20C. Enlarged and diminished, you have to calculate the magnification. Magnification is always V by U. Now based on the mirror or lens, there is a plus minus sign is there, but this will give you an idea that whether it will be enlarged or diminished. If it is negative, inverted, but we know that if it is a real image, then it will always be inverted, no matter whatever the mechanism you are using. If it is a virtual image, it will always be erect, but magnification is V by U. Okay, irrespective of enlarged or irrespective of erect or inverted. Okay, so the gathering of the focusing mechanism is wave nature of light. You have to remember that this is not C. Okay, A and B is for function of rod cones, and there are two types of cone, right? One is rod cells and another is cone cells. Okay, rod cells and cone cells, they work partially on the principle of wave nature of particle nature of light, but our eye lenses, okay, the gathering and focusing mechanism can be explained using wave nature. This is why it is very, very important. Students tend to fall for this question. Okay, and this is from your NCERT book, textbook. The slope of stopping potential V0 versus frequency nu in Einstein's photoelectric equation. Yes, game over. Okay. Sir, which formula to use? 1 by F is equal to 1 by U plus 1 by V, or 1 by F is equal to 1 by V minus 1 by U? Pop chips, you have to remember that for mirror equation, mirror, okay, mirror, if you are writing 1 by F equals to 1 by V plus 1 by U. For lens, 1 by F equals to 1 by V minus 1 by U. Okay, so those both equation can be used based on what system is given to you. So now, what is Einstein's equation? E V naught equals to h nu minus phi, or stopping potential versus frequency. So V equals to h by E into nu minus phi by E. So the slope is y is equal to mx plus c. This is the standard equation. So this must be slope. So slope must be h by E. Option B. 21 is B. Yes, Nigesh. Yes, Suhas. Correct. Next question. The alpha particles are H atom, H plus atom, hydrogen, helium atom, helium plus 2 atom. Sir, please just any trick we not know, cause 2-3 MCQs in paper, how to guess that correct answer. Smiley, it depends on the MCQ. Okay, it depends on the MCQ. One way I told you how to guess the answer in case of match the following type of questions. Okay, match the following type of questions. You match whatever you are sure and check if that match is unique or not. If that is not unique, then you have to do another matching. Okay, after second matching you have to check. After second matching obviously you will get the correct answer, but most probably there is a pattern I have seen that in match the following type of question. Match the following is, by the way, considered to be hot question. Okay, because it is little bit critical that you have to think and answer. So match the following type of questions, and there is a high chance this year there will be a match the following question. Okay, if there will be match, then there you have to identify the correct match. Okay, so unique match, check the unique match, and based on that you can answer. Okay, if U or V negative given, we substitute in the formula. So U is always negative. U is always negative, and as I said, concave means focal length negative, convex means focal length positive. That while substituting in the equation, you have to substitute accordingly. Okay, if the V is given, okay, V is given, V is little complicated based on what is given, mirror given or a lens is given. Okay, and if it is given in case of mirror, whether it is virtual or real, based on that you have to identify the sign. Okay, as you remember old thing, I always say that remember your XY axis. XY axis, your mirror or lens is located here. Anything which is on the negative side is negative, anything on the right hand side is always positive. That's it. Okay, your old XYX diagrams that you used to draw, this is the very basic thing. Yes, it is He atom, option C. I see you have answered it. Next question. According to Louis de Broglie, waves associated with orbital electrons are progressive wave, stationary wave, longitudinal wave, continuous wave. I have explained this today. Sir, how do we know that how to radius of curvature is negative for lens formula? See, suppose this is the lens given. Okay, this is the lens given. So this is the surface, this is one other surface. Okay, so first surface is this one, R1. Second surface is this one, because light is traveling from here to here. Okay, so if it is a convex lens, first surface will always be positive. Okay, second surface will always be negative. And in the lens equation, if you remember, 1 by R1 minus 1 by R2, so for a convex lens it will become 1 by R1 plus 1 by R2. Okay, you don't need to remember, I am giving you a shortcut trick if you want. This is very worst situation if the question comes based on this, but if you want to remember it in future, that focal length is basically n minus 1 by R1 plus 1 by R2 for convex lens. For concave lens it is 1 by F minus n minus 1 by R1 plus 1 by R2. Okay, this is for concave lens. Convex lens, concave lens. You don't need to remember too much. This is always positive. Sign is always positive based on the lens, was plus or minus, there is outside of that. But in your most cases, R1 is equals to R2. So don't worry too much about it. Okay. A sign. Any other doubts? I am coming guys. Please let me complete the MCQs first. Many of you are following me. Let me complete it. So it is called progressive wave, stationary wave. This is stationary wave 23B. So let's solve the MCQs quickly so that I can get back to all of your individual doubts quickly. Okay, I have 6 more questions, so I want to complete it first. So Mn and Mp represent mass of neutron and proton respectively. If the element having atomic mass M and N neutron and Z proton, then correct relation will be M is less than Nm Zmp, M is greater than Nmn Zmp, M is equal to Nmn Zmp, and M is equals to N times M plus M. Very easy question. 24A. Yes, I want to complete it. I will come back to your doubts. Radioactive substances emits alpha rays, beta rays, gamma rays, all of the above. All of the above. All of the above. Yes, D. Yes, D. Don't ask questions. Nigesh, don't ask questions. Your exam is tomorrow. You have to answer it. Right? Semiconductor doped with the donor impurities. Donor impurity means what? It is giving. What it can give? It can give only one thing. 26 now. Nishchal saying 20. Yes, Nishchal, n type. Giving means only thing it can give is electrons. Okay, only thing it can give is electrons, only thing it can take is electrons. If it is taking electron, that is an acceptor, then it will be a p type. If it is giving electrons, then it is n type. Now, which of the correct diagram for a full wave rectifier? Full wave rectifier. (27A) yes. 27A is the full wave rectifier. Now let's move on. 28. N-type semiconductors is electrically positive, negative, neutral. As temperature increases, it becomes negative. So N-type semiconductor is electrically 28B. Any semiconductor, N-type, P-type, intrinsic, extrinsic, they are always electrically neutral. They are always electrically neutral. Does not matter if it is N-type or P-type or any other type. They are by default electrically neutral. Only thing that we are doing, we are making some electrons available to the conduction band. Okay, but total number of protons and electrons inside the atom, inside the crystal remains same. So if the total number of electrons and protons remains same, that means it is electrically neutral. Only thing we have done, like in metals already have free electrons, right? So that is basically, but they are still electrically neutral. Similarly, N-type or P-type or any other type, okay, they are always electrically neutral. This is very, very interesting. Sir, will DD sir take class today? DD sir is whom? Yes, 0, correct. Maths sir, no, maths sir, I don't know. Nigesh, your maths exam is over, no? What doubt you have? Okay, for JEE Advance, there will be no live session, Nigesh. What you can do, you can ask in the, there is a form shared for physics doubts. You can ask, mention sir's name. Ankit sir, his not name is not DD sir. He is Ankit sir. You can ask Ankit sir, I have a special doubt. You can mention the question. You can take the screenshot of the image as well and paste that in the link in the box that is given. Okay, I will ask Ankit sir, he will check the questions and you will get your answers in our WhatsApp channel. Okay, so if you have not followed our WhatsApp channel, don't forget to follow it. I will try to make sure you will get your answer of that question. Either at the comment section of this video you will get a link, or I will ask him to share a link in our WhatsApp channel. You can get that answer there. Okay, right? 29B in electron, yeah, she is saying 29B. So in the equation A equals to BC, A is current density, C is electric field, then what is B? So J equals to sigma E, sigma is conductivity, so correct answer is conductivity. Okay. There was a question where student this was asked. Okay, you should remember that 1 by sigma equals to rho. Okay, if this is coming on the other side, you have to mention that is a resistivity. Now, a rectangular coil carrying current is placed in a non-uniform magnetic field. On the coil, the total force is non-zero, force is 0, torque is 0, none of these. Rectangular current carrying coil kept in a non-uniform magnetic field. Okay, non-uniform magnetic field. Mallikarjun, you are saying okay, option C. Non-uniform electric field. Uday is saying 30D. Hello Chandan, you missed the entire class today. Anyway, I discussed a lot of things today. So obviously it is force is non-zero. Torque obviously not zero. Okay, torque acting on a coil in a magnetic field gives rise to the AC generator, right? We make AC generator in that, right? AC motor, sorry. Motor is based on that. So if this is a current carrying coil, definitely it will experience a torque. But if it is a non-uniform field, then it will not only experience as a torque, it will also experience a force. Okay, so force is not zero. Okay. But sir, still have both force and torque. Yes, force and torque is obviously there, but force is not zero, torque is not zero. Okay, only force is not zero. Given is correct. Yes, if you are saying that, but torque zero is not correct, right? But this is correct. Force is not zero. If you are saying none of these, that means even force non-zero is not correct. Right? Force and torque both can be non-zero, but in the option you have to see whichever option is given as correct. Right? So in this option, force not zero is the correct answer. Okay, so even though it is not 100% correct, 100% complete, but this is correct statement, right? Complete would be if they say force and torque is not zero. I agree, but from the given option, this is the correct, most correct statement. Right? Okay, now what is the doubt that someone asked previously? If you have any more doubt, Mukesh asked, is MCQs will be more tough or easy? Please tell me, sir. Also, please tell me whether the MCQ should be tough or easy. Hajira also asking some doubt about 20th MCQ. Whatever doubts you have, please mention right now. Okay, I will, otherwise I will close it in another 2 minutes. Okay, so MCQs, as I mentioned in my all the videos, there will be 3 MCQs which will be tough. Other than that, all the 12 MCQs will be solvable easily. Okay, 3 MCQs by default are HOTS MCQs. So maybe only 3 MCQs will be difficult, not super difficult, not out of the world. Obviously, nothing that you have not studied, nothing that you don't know. You know the answers, you know how to answer them as well. Only thing is that in the heat of the exam, keep your cool, stay calm, don't get overexcited, don't get underwhelmed that I can't answer the question. Don't get excited or don't get tensed. Stay calm. Okay, whatever you know, when you are calm, you can answer the questions easily. Okay, if you are very tensed, I will not be able to answer. There are some students I know, they are toppers, but still in the exam hall they panic and they falter due to this panic. This is your board exam. You should be able to write the answers now, because I have made sure that you have prepared well. So if you are following my lectures from the beginning, then definitely you will be very confident in the going into the center. You can raise your collar and you will say that I am the Thala of this area, I am the king, I can answer all the questions, right? Yash is saying, please explain lens maker step by step. Okay, I get that. Mukesh Chaudhary is saying, sir, I have a doubt in question number 11, which today's question number 11 or some other question number. Today's question number 11, how to find the current lead lag in case of voltage. Vignesh, I explained it. Let me go back. First, Mukesh, today's class, right? Mukesh, question number 11 in today's class. Let me go back to the question number 11. One by one, I am take all the doubts. Okay. Electromagnetic waves with lowest frequency is radio waves. What is doubt you have? Yes. This question, Mukesh. Adistar is saying XC greater than XL. XC greater than XL means current will lead. Okay. XC greater than XL is current lead, XC less than XL is current lags. Gamma ray has highest frequency, lowest wavelength. Question was lowest frequency, not highest frequency. Gamma rays are highest frequency, lowest wavelength. Radio waves are lowest frequency, highest wavelength. Okay. Sir, explain moving coil galvanometer. Moving coil galvanometer, you skip it. It will not come. If maximum, it will come expression or NBAW omega, that is the rotational part of it. It is complicated, it is very theoretical. Other than that, you can skip that. You have to draw a lot of diagrams for that moving coil galvanometer, but you can skip that for now. Only formula you can remember that NBAW, not NBAW, it is NAB by K, I think. Okay, so phi equals to this formula you remember. Okay, for moving coil galvanometer, this is the deflection of a moving coil galvanometer. This constant is called galvanometer constant. Okay, generally we represent it by G. So this is the deflection of a moving coil galvanometer. You can skip that. Okay, super theoretical question. You have to draw the diagram, explain the diagram well, and first let me go back to Yash's question. He asked me to explain lens maker formula, right? Amish Shetty, force on a current carrying parallel conductor. I told that is a important question, not sure short question, because from this chapter there is another important question, point on magnetic field on the axis of the circular current loop. So that is also very, very important. Okay, now let me go back to the ray optics chapter. In the alternating current, I mentioned current lags, current leads. Okay, I mentioned when current will lead, when current will lag. I missed one formula, that is resonance frequency is 1 by 2 pi square root of LC. Okay, this is also important. Ray optics chapter. So in the ray optics chapter, lens maker's formula. Yash is there with me from the morning, so let me answer his question quickly. So first, what is the thing? You have an object kept some distance, say u, from the mirror. Okay, this is the surface, first surface of radius of curvature r1. This is the second surface of radius of curvature r2. Now remember that when we apply lens maker's formula, do not apply sign convention. Sign convention is not required while finding the formula. So this is the first surface. Okay, when you consider the first surface, what is the meaning of that? You consider that there is nothing, only everything is this spherical surface. Okay. So everything is this spherical surface. There is an object, refractive index is n1, refractive index is n2. Okay, this is a curved surface of radius of curvature r1. Okay, object distance is u. So if this ray falls over here, after refraction, this suppose meets at some distance, and this distance we are saying v dash. Okay, this distance is v dash. Now what is the formula, how to remember it? First medium n1, second medium n2, object distance u, image distance v. Now in back of your mind you remember the lens equation, that is 1 by v minus 1 by u equals to 1 by f. That you should remember behind your mind. Do not show that equation in your answer sheet. So what is the starting point? Starting point is 1 by v. So instead of 1 by v, what we will do, where v is located? V is located in N2. So we will write N2 by v. So basically lens equation only, but in slightly modified, because this is not lens. Minus N1 by u equals to, okay, what is the final refractive index? Final refractive index is N2. What was the initial refractive index? Initial refractive index was N1 times or divided by radius of curvature. Okay, so this is the first equation. Now what happened? This is not entirely N2. We have a second surface. We have a second surface because it is a lens. We have a second surface, and because of this second surface, the light ray after refraction, it suppose it the light ray after refraction, it reached over here. Okay, so this is the actual distance v. Okay, now we will consider only this medium. Okay, refractive index here is N1 back again. Okay, so and the radius of curvature of this is R2. So how to do that? Again, u will be, this v dash will be new u. V is obviously the final v, and where v is located? V is located in N1. So N1 by v, that is the object image distance, minus v dash is the new image object distance. So where v dash is located? V dash is located inside N2. So N2 by v dash equals to, what is the final refractive index? Final refractive index is N1. So N1 minus N2 by R2. Right? Now if you add them, what you will get? This will cancel. You get N1 by v minus N1 by u equals to, if you make this N2 minus N1, okay, then this will become negative. So you will get 1 by R1 minus 1 by R2. Okay, if you see, that is N1 minus N2, but we are writing N2 minus 1, so it will become negative. Okay, now you take N1 common from this side, 1 by v minus 1 by u equals to N2 by N1 minus 1. Okay, into 1 by R1 minus 1 by R2. Now be careful, do not put f, because you know lens equation, it should be equals to f. No, while doing lens maker's equation, you are not using lens equation. It should be independent. Then how can we do that? If the object is at infinity, okay, that is parallel rays falling into the lens, after refraction, they always focus at the focal length. So if u is infinity, then v becomes f. That is the definition, right, of focal length. So put that value here. So 1 by f minus 1 by infinity equals to refractive index of 2 with respect to 1, N21 minus 1 by 1 by R1 minus 1 by R2. Okay, now this 1 by infinity is definitely 0, so that will be gone. So you will get the final lens maker equation. Practice it once, it should be staying with you. Very easy derivation. Only thing people struggle is how to remember this part or how to remember this part. Okay, so when you are treating the first medium, ignore or forget even if there is a second medium. Okay, and always refractive index divided by the corresponding distance minus refractive index divided by the corresponding object distance equals to final minus initial by radius of curvature. Okay. Tolun classes is asking, sir, how to manage the time, sir. So okay, so first I will give you a suggestion whether to follow it or not. That is up to you. You have to answer 70 marks and you have except the reading time you have you have 3 hours to write the paper, right? 70 marks. Okay, so 180 minutes to write 70 marks. Okay, so almost 2.5 minutes per 1 marks. Okay, so when you are answering 2 marker sections, so you are supposed to answer them in 5 minutes, but you can save time for 2 marker and 3 marker and use some extra time. Use the extra time in derivation section and in numerical section. So first I will suggest, if you don't write the MCQs first. Okay, so many students I have seen, they don't write the MCQs first, or what you can do, always compulsorily leave the 1.5 pages for answering the MCQs. First 1.5 pages you have to leave for MCQs. Start with the MCQs, you know, just write them, write the question number, correct option and answer the option as well. Don't leave that place blank. You have to write the answer as well. Whatever you know, write it down quickly, leave, fill in the blanks also the same way, leave, then answer the 2 marker section. 2 marker section takes, answer it one by one. 5 2 marker you have to answer. I would say you maximum you can take 20 minutes to finish the 2 marker section. Okay, 20 minutes to finish the 2 marker section, then another 30 minutes to finish the 3 marker section. Okay, you take 1 hour, almost 1 hour to finish the derivations. Okay, 1 hour to finish the derivation, 30 minutes for numericals. You have to only answer 2 numericals, whereas 3 derivations. So derivation you can take a little bit time. So you still have around 20 minutes time in your hand. That 20 minutes time is very important to check all the answers, whether you have written all the answers or not, whether you have all the MCQs that you have left behind. Okay, so that is very, very important, whatever you have left behind, whether you have answered all the questions or not. So last 10-20 minutes revision is very, very important. Okay, rest time management is not super difficult. So first obviously go through the question paper when it is given to you for the reading purpose, read the question paper completely, then you start answering it. Okay, time management is not super difficult. Run squad, good question. Okay, any other doubts please guys? I want to check if you have any doubts. You have to write only the answer, Shweta. Shweta, you only the answer is sufficient, question number and answer is sufficient, no full sentence is required for fill in the blanks. Yes, next class will be just a 30-minute quick revision tomorrow morning. Okay, and then after your exam is over tomorrow, sometimes in between 2 to 3, I will come back with the solution of your paper. Obviously, all the MCQ answers, all the numerical answers. Okay, and I will also analyze the paper if this is difficult or hard or easy. Okay. Yes, as long as you mention the part, I told you yesterday also, as long as you mention the part, okay, part A, part B, part C, and all the part questions are written at the same place. If you are starting with part E and you answer part E at one place, it is fine. Okay, part E should be written at the same area. If you are writing part E one question here and again in the last of the paper, that will be very difficult for the examiner to examine. That is why always try to write one single part at one place. It does not matter which you start off with, that is completely fine with you, but you have to write all the parts at one place. Okay. Yashu, if you have not studied ray optics, yes, you can skip right now. No, don't waste times on chapters you have not studied. If you have not studied ray optics, you can skip it. Okay, there is no other thing I can suggest. Obviously, questions will come from ray optics, that you cannot stop. But if you have not studied, don't waste time on ray optics. You study your strong chapters. Whatever you are strong at, you study those chapters first. That is first task. Okay, yes, Jai Hind. Jai Hind. Can we skip ray optics? I told you. Yes, you can get out of out, no problem. If you skip only ray optics, you can still get out of out, no problem. Okay, ray optics is important for numericals and possibly one 5-marker derivation might come. Okay, but if you skip ray optics, you have to be reliant on alternating current. Again, you have to be reliant on current, electricity and electric charges and fields, from where you can expect the numerical question. Okay, it is possible to get out of out if you are strong enough. Okay. Answer the hot MCQs will be in the what form? Does there will be a diagram based question? Maybe, Mukesh, maybe there will be a diagram based question, maybe a statement 1, statement 2 based questions, maybe it will be a match the following table type of questions. We are not sure what type of question. Maybe it is just a difficult question which you need to think before answering. Okay, there can be any last year there was a very small numerical question came for as a HOTS question. Okay, what is the energy stored in a capacitor? Small question, half CV square. Easily you can apply the formula and you can calculate it. So you do not know what type of HOTS question you can expect. HOTS question can anything where you have to use your head. It is not just read the question and answer. If it is read the question and answer, they are not HOTS. HOTS question where you have to apply some of your brain. Yes, Yashu, you the numericals, if you solve, you will get all the 10 marks. Sure. What is your question, sir? Complete syllabus and no time and revision time mentioned, sir. What to do? Tips. Tolun class, what you can do, revise whatever you have studied so far. Incomplete syllabus is fine, but you should have taken care of that at the beginning when we were trying to teach you that you should listen, but you are saying, "Arey, exam is still far. You ignored the warning sign for a long time. Now, right now, what you should do, whatever chapters you have studied, whatever concepts you have studied, focus on them. Okay, I will share this PDF. This PDF has all the important questions from the chapters. Okay, whatever chapters you have think, okay, I have finished electric charges and fields, I will, whether I have completed all the questions from this chapter or not. So whatever chapters you have completed, don't skip any questions from those chapters. That is very, very important. Okay, if you have not studied ray optics, fine. If you have not studied some other chapter, very fine. But there are few questions, for example, fixed question, semiconductor. Okay, so you cannot skip that chapter. Even if you have not studied that, the full wave and half wave rectifier, just go through my notes. I have given a very simple, easy notes from those questions. Go through that and memorize that. So those are the very few questions. I have given a top 50 questions yesterday video with 10 derivations. Go and check that out. That will also help you to score 40-45 marks, right? Sir, done with everything but only 2 and 3 marker marks. Can I refer to your video? Yes, Bharat, I have made that video only for you only. Okay, all 2 marker 3 marker videos. MCQ, don't go for MCQ videos if you have not watched it, because MCQ videos are long, so don't waste our time on that. But we definitely 2 marker 3 marker and derivations as well as numericals, all the videos are very important, all the questions are very important. If you check that out, if you need any clarification, any doubts, do that. But I will suggest, don't study anything new in terms of derivations, don't study anything new in terms of numericals. Okay, that is my suggestion. You can, if you have practiced numericals from the chapter alternating current, you can do a new numerical from the chapter. But if you have not studied numericals from, say, ray optics, don't study that anymore. Don't include a new chapter into your roster. Okay, whatever you are doing, continue to do that. Improve those areas faster. Okay, so it will be given as soon as the lecture is over. It will be available in the Google Drive link. The Google Drive link was shared in our WhatsApp channel yesterday. If you have not joined our WhatsApp channel, go join there now. Rekha, sir, what charge does a rod attain when rubbed with cloth? So it will depend on what type of cloth you are rubbing it in. Okay, so basically if you are rubbing a glass rod, okay, generally glass rod gains electron and becomes negative, and the wool becomes positive. Okay, that is your question. But it can depend. There was a electronegativity table in the past. Based on that table, you can guess which one will become negative, which one will become positive. But that question will not come. It came in 2023, I know, because that time syllabus was not deleted. That experiment was part of your syllabus. It will not come in your board exam. Okay. Tolun, you don't have time to follow the question bank. Question bank is huge. Okay, question bank is huge. You don't have right now time. What you can check is my 50 questions. That is a very good part. Or if you don't want that, if you want much lesser than that, you can follow the passing package I released almost 2 weeks back. Sir, from morning I am seeing with breaks. I appreciate your teaching, sir. Thank you, Adistar. I know you are there from the morning. Okay. Topper money, I am bored and yes, I am ending. I am done. I am also exhausted. There is no such doubt. Sir, tomorrow 2 or 3 marks tough. I don't think there will be any tough question. See, only 8 mark questions will be tough. 1 will be your numerical, 5 marks, and 3 will be your MCQs. Other than that, all the questions will be answerable. You will score at least, if you are following me for last at least 1 and 1.5 months, you should score more than 60. If you are following longer than that, you will score 70 for guaranteed. Okay, so with this note, I will end this lecture. The PDF with all the important questions is available in our Google Drive link. So see you tomorrow with a very quick short recap. Till then, bye.